Yeah. Yeah. Sure. I'm Alex. Nice to meet you. You're with me?
1, 2, 3. Yes. All right, should we start? Hi, everyone. Microphone is working. Hello, hello. How are you doing today?
Hello.
Yeah. Should we start?
Yes.
So if you don't mind, we are starting now because here streaming also going on. I am super happy to be here and to see you all here in Amsterdam. Today, my talk is about powering AI capabilities with API management, specifically with API gateway because it's a heart mechanism of APM, right? First of all, let me introduce myself. Let's come in. My name is Babur, which means tiger in English. My last name can be translated like a livermore. It means tiger who is living longer in this life, right? You can call me Babur or tiger. Or reach out to me on these social channels. I will be always happy to have a chat. If you have questions regarding my session, always welcome. Here's the agenda for today. We'll shortly talk about specifically what is the open source Apache API 6 API gateway, right? And then we're going to go through the benefits of using API gateway with OpenAI or chat plugins, which is a quite new topic, right? And how we can use not the ChatGPT plugins, but API gateway plugins to enhance these OpenAI capabilities, right? And I will show you how you can configure primary edge functionalities for OpenAI API. If you are already working with some AI functionalities, I will have a short demo at the end. I hope you will love it. So let's start with APIs. APIs, we know that just the 3 letters, right? By now, we are all familiar with this term. Now, raise your hand if you don't know what's API. Everybody knows, right? Just application programming interface, right? Which is, everybody's APIs, like, because even ChatGPT uses API, right? To retrieve some REST functionality through using the REST, some AI-generated models, where OpenAI has recently launched chat plugins capabilities where you can use or you build your own plugin and add extra intelligence to your open API data, right? That's right. We need to build our own new API or use existing API for our ChatGPT plugins. That's my talk is about, how you can integrate your API with OpenAI, and then next, how you can use it for ChatGPT plugins. So, and we know that success of any service nowadays, if you are using API-first approach, depends on performance, availability, and integrity of your APIs, right? Every service. And here is a question raised, another question, like how we can achieve these 3 indicators of success. There are many ways, right? We need to continuously monitor, we need to deploy somewhere in the cloud, and so on. But somehow, how we can achieve it, my solution is using API gateway. One way of achieving these 3 indicators and to build successful service or ChatGPT plugin service. Because nowadays, we are, exposing functionality of single product by using multiple microservices or serverless APIs, or maybe some sort of GraphQL, which is just retrieving data from database. And the consumers need to consume API functionalities from more than one microservice, right? In this diagram, who doesn't know what's API gateway, it sits in the middle, which routes incoming requests to the internet destinations, right? Internet destination can be everything. It can be third-party service or maybe gRPC APIs and so on. In other words, it acts as a sync layer between your clients and the backend service network, right? Now we know what's the API gateway, and now let's say what's the API gateway plugins? They are just additional component, right? Where you can add this component to API gateway to make more further extended functionality for your API gateway, right? To provide some cross-cutting concerns, like we say authentication, security, traffic control, caching, cellular transformation. There are a lot of modern API gateway features nowadays. You can use for ingress controller also. My colleague on the first floor was also talking about how you can use API gateway for ingress controller. There are a lot of solutions in this modern world. But today I'm going to talk about specific API gateway. I'm not selling, of course, but I'm just representing API 6 because it's a nice feature. It has a nice features because it's under Apache Software Foundation. Maybe you are already part of it. Raise your hand. Who is actually committing or committer of ESF? Like a Kafka. Do you know Kafka, Cassandra, Tomcat, all these Apache Software Foundation projects, right? Nobody uses or contributes to open source? No? You? Okay, which project? Oh, yeah, it's so great, yeah. API 6 is also one of the top, fastest growing project of API 6 or Apache Software Foundation, which is called API 6, right? Why API 6? You can ask, because there is actually 7 continents in the world, but 6 means in China, as I know, it's some successful number. That's why they call it API 6. Not a 6th version of API, but just successful number. So, and why I like this, because sometimes you use existing plugins, right? Existing plugins, or sometimes you need to create your own plugin from scratch because it should meet your customer requirements. And I can create my custom plugin and in the programming language that I am familiar with. Like I can use Java because I'm a Java developer, or I can use JavaScript libraries or a plugin runner to build my own plugins. But if you are lazy enough and you don't like to write the code, you can use a dashboard. It's also open source friendly UI dashboard where you can just build your own plugin by combining one or multiple plugins together. Just on a drawing board, right? You can just put some conditions and where you can specify some authentication rules, rate limiting, and so on. And here we go. You will have a ready plugin, and you can export it as the OpenAI specification or YAML JSON file and use it somewhere else, maybe some other Open API gateways. This is the dashboard, what I like, right? Next, now switch back to the main topic. What is the OpenAI API? Who knows? Who knows OpenAI API? No? Did you did you try to use API by using tokens, retrieve some AI models?
We're starting to use it.
Yeah, starting. Okay, me too. I also tried to create this demo specifically by experimenting, talking to the API, because API, of course, just exposes some powerful AI models through some endpoints, right, to you instead of using a dashboard UI. So as a developers, I use API, right? Instead of using, I would say, UI, or I can use CLI tool. So this API actually some endpoints where you can make a text compilation, right? You just ask something, AI responds to you. If I ask, give me product description, what's the Apple Pro 13? It can provide some description, right? Or you can do some code compilation, right? You can write some code, and then it can help you to find out bugs and so on. This is AI capabilities. Or you can generate images from text, or you can send the API one image. It will create some variations of different images, right? There are only 3 features I listed out here. Actually, read a lot of them. OpenAI that offers, right? And what kind of integration benefits you can get out of integrating API gateway into OpenAI? First of all, scalability, like means You can scale your APIs how you want, horizontally. Like if one API service is failing, another API service can get the job because there is a routing mechanism that API gateway offers, right? Next one is performance. You can enable some caching in the middle of OpenAI API gateway, and client. API gateway can cache your response. You don't have to worry about spending your API account usage, right? Or if the same response you need, but multiple times you are using caching, can help it. And observability, for example, one of those good point, you can monitor, you can check metrics, logs, and so on using the same API gateway or API management in total. API management is just with portal and with UI, right? And most important is security, how you can secure your ChatGPT plugin APIs or OpenAI APIs using API management. You can achieve that. With the help of plugins. I listed some of the plugins, 6 main plugins, like transformation, caching, and so on. You can have a look. So, and now let's switch more theoretical, practical part, enough theoretical part, right? Now we have a knowledge, we know what's the API gateway, OpenAI API, we know what's the plugin. Am I right? Or, okay. This is actually, I draw the diagram, how it looks like my demo. Let's imagine that I have a client application, mobile application maybe, and then I want to build one single page mobile application where I need to show to my clients, where my clients can type, please provide me this product description, or please give me this information about this food, and then AI responds. And generate some response, but uses in the middle API gateway, because, well, why we are using API gateway for routing requests, because we might have not only one single API endpoint, maybe multiple, because routing can route automatically, and to manage our API consumers, because we can have one or more API consumers, right? We can share our tokens and so on. Actually, as you can see on the right side, /v1/completions endpoint, coming from OpenAI. You can check it out on the website, the official endpoint, publicly available, but you need to access it by using tokens. And what I'm doing, I'm putting in the middle my own website, mywebsite.com, which is using API gateway to make these functionalities available. But I am exposing this product description endpoint with my custom domain and URL path, right? As you can see, mydomain.com/OpenAI/product/description. And this request will be forwarded to OpenAI. OpenAI responds, and in the middle, I'm doing caching, observability, API consuming, and versioning, and so on. Is it clear why we are using here API gateway? Or does it sound good? Or good. In this case, let's jump into the demo, how we can achieve that. I'm going to show you. If I switch back, first thing, of course, who doesn't know what's OpenAI API? This is actually the website. Everybody can see, right? That's good. And here's the website. First thing, you need to create an account, free account. It's $18. You can get monthly to retrieve some OpenAI requests and responses. You can generate some secrets to access this API, or you can upgrade your account into OpenAI Plus, which is $20 per month. But I think I'm still using 2 months is free. It's okay. It's enough for me. So first thing, account, API keys. Once you get API keys, you can just read out some documentation, of course, how you can use this API, how you can authenticate to this API, for example, by using bearer token. This OpenAI gives you bearer token, where you can put this token in the authorization header, here, as you can see, and then start the request and create something great for your customers, right? So I will leave it for you. Now, what I want to achieve is, as you can see, you can find also my demo today here, for example. Let me also present here, which you can scan. If you scan this QR code, there is a GitHub repository. I mean, this presentation will be not enough, 20 minutes. There is a full guided tutorial. You can read it out and try yourself with API 6 and OpenAI how you can achieve some cross-cutting functionalities. If you scan it, I will just switch it off. Okay, okay, I think it's a bit better. This is my repo I created before our talk for you, because 20 minutes always not enough to cover this long topic. It consists of basically this URI. There are some API 6 projects with Docker Compose. You can bring some necessary containers. There is also blog post. You can read it out, how you can do a step-by-step. And there is also curl commands. Because I love the curl commands, you can use Postman or Insomnia to achieve the same, but there are some step-by-step how you can integrate this OpenAI API with API 6. For example, you create upstream, you create a plugin configuration, you create a route, step-by-step, just follow the numbers. Right? And then you do some complex things, how you can do canary release. And you can publish your first API publicly and maybe deploy into the cloud, like Azure cloud. What is your favorite cloud? You can just deploy it. So let's start it. I have downloaded this project. I am already running. I have this example curl commands folder is opened, and I am using Windows machine, as you can see, because I was working at Microsoft for a while. I don't have a choice. I used Windows, and you can use Docker desktop installed on my machine. And as you can see, I did Docker Compose up. I have some containers like API 6 dashboard. If you don't want to use curl, you can just use dashboard or some other things like Grafana, Prometheus for monitoring. And let's go by, as you can see here, I hope this is big enough. This is actually OpenAI completion endpoint. I want to ask AI, please provide description, product description for Apple 13 Pro. You can replace, of course, any keyword. And up to 256 characters should be the response. If you don't specify it, you will get a long book. What is the Apple from the Steve Jobs stories? So that's why I just cut it off. Let's run without API gateway. I'm not using API gateway. As you can see, I have bearer token. You can just hit copy and use my token. But just copy this curl command and put it in terminal. I can open maybe another terminal to show you. I hope we do have still some time, right? If I press this, as you can see, it takes some time because the AI should generate some response, right? As now my response coming from AI. As you can see, Apple 13 Pro is perfect laptop. I know, but it's not perfect in terms of money. It's too expensive. You will get this response back. Now there is no API gateway. Imagine there is no API gateway. And now my task is to enable API gateway, put in the middle of this request. Instead of directly reaching OpenAI API, I will reach first my API gateway, and API gateway forwards the request. To do so with API 6, with most of the open source API gateways like a Kong, you should create upstream service. You can use curl command to access, let's say, admin API to create your for upstream. Upstream means your backend service. Backend service, in my case, OpenAI API, right? And you can register also nodes, one node or multiple nodes. Why we need nodes? If one node fails, you can always fall back to next available node, right? For the simplicity, I'm using only a single node, but you can use multiple nodes as well. And I'm using some sort of algorithm, round robin, just simple algorithm to route this request. And scheme HTTPS means securely connect OpenAI API because it requires to have some certificate and so on. But of course, you can use TLS connection if you wish. And next, let's create this upstream first. And now API 6 response, okay. Your upstream, your backend service registered. OpenAI API now it's ready, but still we need some plugins, right? Plugins for what? Plugins to rewrite our request coming to our custom slash product description to V1 completion. That's why I'm using a proxy rewrite plugin here. And I'm rewriting host, I'm adding headers because OpenAI API accepts headers with authorization token, right? That's why I need you to use this plugin. Let's create this plugin configuration, again, using admin API of API 6. Maybe it's better I put, and again, like open another terminal. If you put press, now the plugin is enabled. It's straightforward, right? And next, third step, now I have a upstream. I have a plugin config. And now I need to create route, which is last step. Route means just checks matching rules. It has some matching rules, which request should go to which backend service. It identifies. So it means we are saying every post request coming to this URI should be forwarded to this upstream using these plugins. Right? Very kind of understandable. 5 minutes left. Okay, thank you. I have also 2 minutes or 3 minutes left now. Now let's create this route, which is the last step. I can create this. I have a route now. So we did only 3 steps, and the last step, of course, just to test if this API gateway is good. As you can see now, only differences with the curl command we did in the beginning, you are saying, you see this, I'm using my domain, in this case, localhost, and I'm using my URI, not the OpenAI URI, right? And I'm sending the same post request, but in this case, API gateway already now in the middle. It's intercepting my requests. If I do the same request now, now my request will go to API gateway first, and will go to OpenAI API and responds back. Again, API gateway gets this response and so sends back to us. But I will get the same response, right? Now, only difference is I can now add extra functionalities on the top of my solution, right? I can create consumers. I can create authentication. I can create also a next version of my upstream when I have 2 upstreams. If I want to add new feature, while keeping the current consumers of using old feature, I can use some A/B testing techniques, right? That's all the capabilities of modern API gateways. Not only API 6, you can check it out. I have a lot of blog posts written about what is the best API gateway for your choice. So this is all about. Before we finish, let me also put some takeaways, like what are the takeaways we have today. So you can use API management solution to control your OpenAI API traffic. You can use Azure API management if you're using already Azure Cloud. It's up to you. Or you can use API gateway like a basics, upstream route, plugins to enable some proxy caching, some security features, and so on. Or you can manage your API consumers using the same API gateway from single entry point. This is my takeaways today. Like now, there are some references. I'm going to also leave it for you. If you would like to learn more about API 6 specifically or API gateway, feel free. So with that, enough for me. Thank you for your attention. If you have a question, we do have maybe a couple of minutes. No? 3 minutes. Oh, we have 3 minutes. Okay, on time. Any questions? And for your question, you can get some medals. I have also on the table, like you can collect. This is actually a medal you can just put here and then go ahead. Yes, thank you.
So how would you sum it up, what you've done? How would you summarize what you've accomplished through this, and what are you thinking next? I'm just trying to get an idea of what.
Yes, very good question. That's why I prepared the answer for your question beforehand. What I did, I have only recording here. I will show you just a moment. I have a recording here. What I did, I created custom connector using power-ups for API 6. Right? You need a custom connector to use on a power-up application. I built my mobile application without any code. I used power-up, as you can see on the screen. What I did, just a moment. I need to keep back here. I built the same, instead of now curl command, I'm using Android application. I'm building iOS application for the same solution. Now I can provide the same product name and specify some character limits and generate some response. This actually uses only the simple backend code, which PowerApps provides, like an Excel function. Right? As you can see, I spent like 5 minutes to build this mobile application. And now it's really a product, right? It's helpful, actually. You can ask everything. It can answer. You see, it's a preview version. If you become my user, I will give you the application APK. Yeah, I'm asking the same, right? The same, and I can generate some response back.
So you created the prompt about Apple to use with the API for your app.
Yeah, great. Yeah,
Okay.
exactly. I mean, no, I can ask everything, not only Apple or certain
It
prompt.
could be anything. You use that.
Yeah,
Right,
yeah.
exactly. Okay.
Sure. Is there a lot of use case, right, for this? You can ask for open flights, or you can schedule something. You can build any mobile application with Power Apps. You can integrate with API management. By API management, I explain it, and also you can use AI. That's modern stack, I believe, nowadays. I mean, if you have a medium or junior skills, you can do this.
So your app will provide product descriptions theoretically, right?
Exactly.
And you can pull it from OpenAI to get that data.
Yeah.
Okay.
Yeah, you get a point, right? Yeah. I spent, to be honest, like to prepare this mobile application, 20 minutes, maybe 22 minutes. I create custom connector, and of course I have free now account. That's why if I show you without demo, it could take a lot of time. Power Apps is working slowly. And this is one of the disadvantages, but this is an application. Yeah, sorry. No questions? And we have our own time. Like, if you have a question, I will be there. You can ask me everything, not only Open API Gateway, but everything. Thank you. Yeah. Thank you. Thank you.
I am. I'm missing the hat. Okay. Can you, is this on? Can you guys hear me?
All right.
No, this is fine. Is this on?
Yeah, it's on. It's hard to hear yourself,
Can-
but you are on speaker.
Can you guys hear me okay?
Yeah, I can.
Okay, good. Good. So first thing you probably notice is that thank you guys. First thing you probably notice is I don't have a cowboy hat. I'm not Cody. Unfortunately, Cody had a personal emergency, so he couldn't be here, and I'm doing the talk on his behalf. We had actually collaborated on this work. So, of course, we can't start without a quote from someone nearby. The context for what we've been doing here is that over the last few years, a number of us, a small group of us actually, who've been collaborating on Kubernetes networking and mesh networking and network security the last few years, we've been sort of watching the evolution of the stack, right? And over the last few years, the stack has actually gotten a lot more sophisticated. And in some ways, we've actually been working with literally dozens, maybe even hundreds of organizations as they've been adopting Kubernetes. In fact, I was talking to a few of you this morning and asked them, okay, look, what's working, what's not? And usually, connectivity, networking, traffic, that comes up at the top of the list. I was actually surprised that it was the top of the list, literally with everyone I spoke to this morning. So, why is that a problem? Generally, there's a reason for everything to be there. And the reason we are actually looking at this is because it's a barrier to entry. For new folks looking to join the platform, looking to use the platform, it becomes a barrier to entry because they have so many abstractions to understand, so many abstractions to figure out, okay, what's not working, how does it work, why does it work that way, right? And for the organizations that go beyond that and start scaling their deployments, the complexity, but more also the resources start to grow exponentially. And we've been talking to organizations that have a handful of clusters, a few dozen clusters, and the amount of resource consumption just for the connectivity exceeds the resources consumed by the application. And in some cases, these are like machine learning shops doing machine learning as a service or other sort of capabilities like that, where the applications themselves are pretty beefy, right? So that's quite a statement. So to give you an example, just put yourself in the shoes of a service owner who's got to deploy one application, deployment version 1, version 1.1 in an adjacent cluster. And so, look, you go ahead and say, great, I define my manifest, and I go and deploy my application. Next step, of course, you've got to define your service so it can be accessed, deploy your service, and give it some, your kubeproxy obviously is going to go catch up and get your kernel rules plumbed, IP tables, BPF, whatever. And most folks these days use ingress, so typically you have to have your ingress resource as well, or your ingress gateway, or your gateway resource. And the reality is most folks today, when you deploy it, you're exposing both your services and your ingress through a cloud load balancer. So wait for your cloud load balancer to catch up. And sometimes it needs to be warmed up. This is all sort of normal. So far, everything is like progressing one after the other. The moment you get to any sort of microservice pattern, you typically need a mesh. Great, so let's go deploy a mesh data plane. Great, so that you've got your mesh patterns. But it's not just a data plane, you need a mesh control plane. So guess what? If you have a typical multi-cluster environment, you've got your mesh control plane as well. And it's not just the mesh control plane. Well, now you have multiple mesh control planes. That's the typical pattern people deploy with. You decentralize your control plane. So they need to be federated. And the moment they need to be federated, you also have other elements like you have east-west gateways, you have to expose services, you might have additional proxies, waypoint proxies, east-west gateways. So it tends to add up. So do you guys see the sort of barrier to entry for new people? And there's a lot of, I see a bunch of heads shaking in the back. There's quite a bit of stuff here, right? And to step back and think about this, the kind of feedback we've been getting from the organizations we've been working with is a typical application owner spends about 10% of their time on the initial deployment. And 90% of not just the time, but the resources, the troubleshooting time, the complexity, the cost is in this other stack. And if you step back and think about this, what does the business care about? The business cares about the application and that it's accessible by clients. Rest of the stuff is plumbing, right? So, and let me pause here, first of all, to say that as we've been going through this, we are not attacking any single one of these approaches. There is a very legitimate reason for every single one of them to exist. In fact, heck, we've actually contributed to a number of these. We've helped in the design of these. And quite frankly, for us, if we had to go back 2 years and say, let's do this all over again, differently, we couldn't have done it any differently, I believe. We would have ended up in exactly the same spot. So what happened in 2 years? So we are all engineers, at least I imagine most of us are. And engineers, we always have a quest. Can we do things differently? Can we try something new? Can we make it better? Can we make it simpler? What happens if we do this? So something's changed. If you step back and you think about what all of these abstractions are fundamentally doing, they are stitching a path through the network. They are wiring different parts through the network. Oh, look, I have a new virtual service instance, and this is the path to get it. And I have a path through this gateway. So let's go stitch that path together. Let's wire that path together. And it's not that dissimilar from a traditional sort of old-fashioned telephone exchange with operators sort of saying, hey, I need to talk to Duffy 4031. And, the connection slowly gets made across a bunch of... And fundamentally, if you step back and think about what we are doing with a number of these abstractions, in fact, almost all of these abstractions, we are stitching paths through the fabric. The way we do phone calls today is not that. You pick up the phone, and you see, you don't see a number. You see who's calling you, right? And you say, oh, damn, it's Andy. I'm going to pick up that phone every time, 10 times out of 10, right? Because guess what? Andy gets priority. Every time I talk to him, I learn something new, right? So you basically go, okay, I need to pick this up. If you get an unlisted number, you can decide, okay, I'm going to ignore it, right? Doesn't have priority. So the world, in the real world, has sort of shifted to identity. You don't go wire paths through the network. You don't call up people by that number, right? So let me take us on a different angle, because what I'm going to be presenting here, in our view, is very transformative. And hopefully, it starts provoking some thoughts in, hey, can we do things differently? And hopefully, the demo that we'll do will come and reinforce this. So let's start by first asking this question. Today, you have to create all of these sort of paths through the network, wire them up, connect all these different gateways together. Let's step back and think about this. We've done this for a certain reason. But now, what if there was a new transport available to us that had more capabilities, that fundamentally was able to do this, or we were able to leverage it much more effectively? And more specifically, what if this transport had identity, workload identity, as a core part of the transport? In other words, how you route, how you send traffic from point A to point B, client to service, is now defined by the identity. And more specifically, in a context where you say, look, every client in my environment is going to have an identity. There's a workload, a machine identity assigned to the client. And so if, as a service owner, you can say things like, look, if I receive traffic from this identity, that identity belongs to this category. They have this certain level of service associated with them, maybe in a service level objective. They need to go here because right now, based on whatever metadata, whatever intelligence, whatever intent, that is the best application instance to deal with that client. And the fabric magically figures out how to get that client to that service, figuring out the optimal path, doesn't care about IPs, doesn't care if IPs are being natted, right? Doesn't care about like what happens in the middle. If that world existed, let's put yourselves in the shoes of the application owner. And what if that new transport was now an internet standard? Not H3, but the technology behind H3, the transport protocol behind H3, specifically called QUIC. So QUIC was a standard as of 2 years ago. H3 is a standard as of a year ago. And there are some phenomenal new capabilities. But let's step back from that. The fundamental thing that we can enable here is separation of concerns. And the separation of concerns means that as a service owner, the only thing that a service owner cares about is, I've deployed my application, I have this other version, I have this other version, they're running in different clusters, different clouds, doesn't really matter. There's some, as a service owner, what I define is, what is the contract I'm presenting to clients? And that contract is based on the client's workload identity. Now, yes, we are assuming that every client in this picture has a workload identity. Some of you may not have that state today, but ask yourself, if you're going to do true zero trust security, don't you want to know the identity of who's talking at the other end of the transaction? Not which gateway it came through, not what IP address was the load balancer's IP when it natted the traffic through. You want to know who's at the other end of that transaction, end to end. So you want client identity. And guess what? If you don't have a client identity, maybe you could say things like the service owner decides what you do with a connection. Do I do some default set of rules, right? So as a service owner, you go, hey, if I get an unlisted number on my phone, I'm just going to ignore it or send it to voicemail. Same thing a service owner can say, I can just have a default set of load balancing rules, a default set of security rules, and so on. But if there is an identity, and the identity says this client or this consumer belongs to this group of identities, oh, that is mission critical. They need a service level objective. This other group of inbound connections, I don't care. I could deal with them as required. But the fundamental benefit here is separation of concerns. As a service owner, you focus only on this side. You do not care what runs anywhere else. You do not, in fact, when you see a demo, we actually don't need any of that stuff. We don't use any of that stuff. But that stuff can continue to exist because everything we're doing doesn't require any changes to the OS, to the platform, to the cloud, no changes whatsoever. We are working at a higher level and leveraging identities. So one other question you might ask is, well, so this is great, but look, it's going to take time to adopt a new technology stack for my application. Guess what? You don't need to modify your application at all. Not a single change. Because we're using this as a transport, as a wire protocol. It's how the packets get sent on the wire. Your application could be sending existing H1 or H2 traffic as it always did. In fact, we'll show that in the demo, right? So literally, the big benefit here, and the reason this is transformative, is because we essentially saying this 10% which is relevant to the business, that's the only thing that matters. And in this new world, this 90% of where people spend their time, no, don't worry about it. It's something that is, as an app owner, you have separation of concerns. Yes, there's still going to be cloud plumbing. There's still going to be other stuff. In most cases, we actually don't need it. We actually can completely bypass it. But this is a fairly transformative shift in what we're proposing. I'll give you guys a second because I'm seeing some sort of little bit of skeptical faces here. But I'm also seeing a few heads shaking, going, this sounds interesting. Good. So let's start by a quick demo. And again, what I'm giving here is a little bit of a teaser, right? Actually, let me set up the demo first before I get to the demo itself. And it's a transport. We are not doing a tunnel. A tunnel implies you need access at both sides of the connection. We are doing a transport. And we're doing a transport that is an internet standard. When you watch this video later, that's the transport you're using because all the web browsers have switched to this transport 2 years ago. This is literally, if you go look at this is 70% of internet traffic today is going over H3 and quick. So this is the new standard. And for us, it's just a wire protocol. The application can still be H3 or H1 or H2. So just to illustrate, I picked one of the standard microservice demo apps. And what it is a bunch of, like a bookstore kind of application. You have an application that talks to a book buyer microservice, which talks to a backend bookstore microservice, which talks to a book warehouse, MySQL database to the backend, right? And the demo I'm going to show you is, actually, I'm going to show two demos, but the one to focus on is, okay, and by the way, there's also a book thief. So it's illustrating another version of the microservice, which may not be trusted. It doesn't have the right identity. So what we're going to show is first, how do we automate identity across this cluster? Oh, and by the way, I'll talk about the multi-cluster as well. But in effect, saying, look, now we've got identity built in, and we can do a progressive rollout from version 1 to version 2. And how do we do that where the service owner does not have to worry about have these rules propagated to the infrastructure, have these rules propagated to client-side proxies, RPC fabrics, whatever, right? So in effect, how do you do this progressive rollout? And the second thing that you'll notice here is now that the certificates, how do we ensure that book buyer is authorized, but book thief, which doesn't have the right identity, is not? So that's the demo we're going to show. And okay, so what I have here is just a running cluster. And there's a few things you'll notice here. Hopefully this is still working. Every so often my two-factor kicks in. Yeah, it's still fine. And what you have here is a single cluster. It happens to be running on AWS. And you have a few things here. First, you have Cert Manager, specifically the Cert Manager CSI driver Spiffy plugin, which essentially what it takes care of is automatically provisioning an attested workload certificate for every workload in the cluster. Attested in the sense of you can establish the trust of the workload. Second, those certificates are short-lived, duration of 1 hour. Cert Manager CSI takes care of rotating those certificates and mounts it as a CSI volume. So every pod comes up with an identity automatically. Second is you have these services that I talked about, book buyer, bookstore, book thief, book warehouse, and so on. They happen to be running in this particular cluster. And just so you know, I just deployed it a few minutes ago. You don't want to go waste your seconds looking at kubectl applies, right? So this is basically what is applied here. So now let's go access the UI for the book buyer as well as the book thief. And to do that, we'll just do a kubectl port forward to access the two UIs for that. Okay. Oops, sorry. Okay, there we go. I've been running this for the last few minutes, and there's a count of books. So if you go look at the book buyer user interface, it tells you, look, right now I'm purchasing all my books from version 1 of the bookstore because that's the only one that's deployed. And if you go look at the book thief UI, same thing. It's actually incrementing, and in this case, it's quote-unquote stealing books. That's the demo application. So everything is going to V1 because there is no V2 at the moment. So let's see what's in V2. So this is the manifest for V2. And it's just the deployment manifest. There is no service manifest. And in the deployment manifest, you see this little thing that says this V2 deployment belongs to this service, so I can associate it with the V1 deployment. They all belong to the same overall service. And the only other thing that is really required here, in fact, this is also optional. In fact, literally, that is the only thing that is required. And by the way, even that can be automated. So the intent is to go from 50, 60, 70 steps to 0. And the other thing you notice here is the weight. Right now, I set a weight of 30. So if the other deployment had a weight of, let's say, 90, 1/3 of the requests have to go to version 2. That's the only thing that's required. The other thing I've just injected in here is to say, now start enable client cert, i.e. do mutual TLS. So previously, I didn't have that enabled to true. Now I'm saying set it to true. And when I set that to true, there is another annotation called allowed identities. And the allowed identity says spiffy : book buyer. So service account book buyer in the book buyer namespace. In other words, I'm not authorizing book thief. So those are essentially saying when I go to V2, only book buyer should work. So let's go deploy that. Okay, give it a second for it to start up. So in effect, what we're saying is we've now deployed V2. When this takes effect, essentially 1/3 of your traffic should go to V2. But in effect, book thief and book buyer, they're both being authorized with mutual TLS. So in effect, in this demo, we've done a progressive rollout, and we've done mutual TLS. So let's see if it started up here. Okay, there's V2. There's just an extra instance that I don't know what happened there. Okay, so give it a few seconds here. The config update takes a few seconds. We could restart it, but it's fine. So in effect, what you should see is, in effect, when this deployment happens, there is some automation happening behind the scenes, which is completely taken care of by us. The fabric, the infrastructure fabric, is being orchestrated by not the endpoints, just the endpoint, just the server side. There's literally no control on the client. The client is simply just sending transactions. It has no idea that this is happening. And the server application automatically takes care of the orchestration of traffic. So there you go. So essentially what you should see is now roughly 1/3 of transactions are going to V2. If you change that weight to 50, 60, 80, depending on the performance, guess what? The traffic will grow. Also, now we enabled mutual TLS. That annotation that you saw, that's designed to be completely behind the scenes. All of this can be automated any number of ways, which we haven't yet exposed in the product, but it's coming. So in effect, what we have said is, to come back to what this demo illustrates, and by the way, I told you about book buyer working. This is book thief's mutual TLS, basically saying book thief is not authorized. So you have mutual TLS in your application too. What I didn't show in the demo is all the observability that shows that mutual TLS is working. These are standard Grafana, Prometheus, the standard observability add-ons. But now linked to identity. In other words, it's not just app A talking to app B, but what is the identity of app A? Is it supposed to do that? So everything is enriched with identity, and identity becomes the core. So in effect, what you saw here is how a bunch of microservices, no change whatsoever. These applications are still sending H1 in this case, H1.1 in this case. We have essentially said that is being converted to H3 on the wire. And by the way, by doing that, suddenly your performance goes up by 1/3 because we're working with a much more optimal transport. Right? And nothing against TCP. I actually have TCP code in the kernel myself from 25 years ago. But there is a number of benefits to the new transport. So the key takeaways are, the single most important point I want to reinforce here is the world has changed, and it is now possible to make life simpler for a service owner. And the service owner should not have to worry about that 90% of other complexity in there. Second, some of the key takeaways I want to reinforce. One is what we're doing does not require any changes to the kernel, OS, platform, cloud, everything is happening as an application wrapper. So it's completely in the application. You could run this anywhere. You could run this on any architecture. You could run it in an edge worker. Doesn't really matter. Your client could be anything. Your client could be a web browser. Pick your favorite browser. It works. Your client could be literally anything. It doesn't really matter. Obviously, the security and traffic management, this is all, we're really focused on microservices. All of the common microservices patterns should be easy. If you think about the separation of concerns, we're essentially saying, look, as a service owner, do not worry about any of the other stuff. Focus on your application, and that's all that matters. We'll talk about some of the cloud builds, but there is a significant amount of resources in the other infrastructure, right? That's just one. There's a few more examples of that. And fundamentally, what you're doing is you're now tying your service level objectives, you're tying your business objectives, your policies to an identity. Hey, this group of identities, critical application. Make sure SLO is protected. The latency doesn't exceed a bound. This other group of applications, you don't care, right? And just to challenge all of us here, this isn't about attacking what you're doing today. There is a valid reason for all of that existing. But now there is a new opportunity. There's a way to rethink how we do this. Make it completely transparent to the application. So the application continues to run unchanged, but suddenly we are saying all of this other stuff that we had to figure out, the 90% of time, resources, troubleshooting, complexity. Imagine if you had 40 different steps to go, or 15 different steps to go, and one of those doesn't sync correctly. How much time is wasted trying to troubleshoot? What is it? Is it a kernel natural? Is it a intermediate proxy? Is it something else, right? Is it a load balancer that hasn't warmed up? All of that goes away. So this is a challenge to all of us. Let's collaborate. Little bit of a, so tomorrow I have a separate talk, but more focused on security, right? But this is a opportunity, and my colleague Rick is here as well. We've been talking about this to a few people here already. Would love to collaborate more, would love to brainstorm more. I know some of you are focused on some interesting ways of leveraging Kubernetes into other platforms, other use cases. Those are all the kinds of use cases we are looking at. We are looking at the next 10 years. We are leveraging technology that will be the next 10 years of your life. This is the way the network is moving to. Come talk to us. I'll take a couple of questions if there's time. Do we have time, Mother? Okay. So any questions? Yeah. Yeah, great question. The question is, sorry, I should have used the mic. Repeat the question. Question is, when I'm talking about efficiency of transport, what am I referring to, right? Latency or others. So there's a ton of literature in the community over the last many years about the benefits of this new transport protocol, QUIC, versus the existing world, right? Including a number of folks who've been the folks who built TCP in the early days, going back many, many years. This is a more optimal transport. It has some characteristics. One is security is mandatory. TLS is no longer an option. It's built in. So to answer your question, we've actually found that despite this additional capability, because the protocol is so much more optimal and efficient, we are actually seeing an improvement in performance relative to the legacy uninterrupted traffic. Roughly, like for us, when we're doing benchmarks with a simple application, for example, we see roughly about a 30% improvement in latency. Now, there's a whole bunch of other kinds of scale testing that can be done. Right now, the big web scale providers are happily doing that because this is the protocol that they are using for exposing their websites to end users. H3 and QUIC is what is running the majority of the internet today. So there is a lot of testing going on, but fundamentally, the benefit we're seeing is literally, well, let's add security, let's add MTLS, let's add this. And yet, we're seeing an improvement in performance. So does that answer your question? Great. Any other questions?
I see a second container in your pods. What's that for?
Yeah, absolutely. So, by the way, that's a good segue for the talk I'll be doing tomorrow, which is no sidecars at all. Today, we have to get the traffic from H1 or H2 into H3 at the server side. That is a simple HTTP to HTTP transaction. And on the server side, we need to provide the intelligence for the application to figure out what the identity-based policies are. So for us, H3 and Quick is a wire transport. But on the server side, on the application side, we are providing it the intelligence. It's how we are building that intelligence into that layer. So fundamentally, what that is a proxy to get the application into H3 on the wire. There's other ways you can do it. There's various ways to inject into that. We'll talk about one more tomorrow, which essentially eliminates the proxy. These days, there's a lot of other ways you can get traffic from an application to the wire without necessarily using a proxy. For this demo, I happen to show a proxy. Similarly, on the client side, you might have seen that there as well, but no state whatsoever, completely stateless. Other questions?
When was the transport introduced?
Sorry. Go ahead, Alex.
You have covered it. When was the transport first introduced, and what's the status of it now?
Yeah, great. Quick as a transport was brought to the internet community by Google many years ago, 8, 9 years ago. It was actually originally conceived at Google. And it went through the IETF standardization process, and Quick was made a standard 2 years ago, officially. But many of the large web-scale providers adopted it because it is the required transport for H3. So H3 is defined to work on Quick, right? HTTP3 was a standard as of last year, but it's already being in widespread use. All the major browsers switched to using it maybe 2 years ago, 3 years ago as the default.
So the original transport. Okay.
Right. Other questions? So let me leave you with that takeaway, guys. Thank you for the time. Hopefully this has been eye-opening. Again, the key point is there's new opportunities. There's ways to simplify the world. And think about this. If you are a service owner, you no longer have to worry about why is this platform so much more sophisticated than everything else. Your application could be on any platform, but you still get the kinds of capabilities that people have historically relied on Kubernetes for. Right? So you get the capabilities, but now in a much more simpler world. That said, thank you guys, and both Rick and I will be around, happy to answer questions and hopefully collaborate. Would love to get more folks collaborating with us. So, thank you.
you.
Okay. We're live.
We're live. We're doing this, friends. Hello.
Shut up. Okay. So we'll talk about Kubernetes, policies in Kubernetes, what we can do with them, and maybe a bit of cross-plane. I don't know what's happening on the screen. You will have to have a lot of imagination if you want to understand what we're talking about. Without the slides. There we go.
Here we go.
So it's two of us. My name is Victor. I do stuff. That's my presentation. And now Whitney is going to introduce herself.
Oh, look at me. I do stuff too. Uh-oh. I broke it. My face on there just broke the whole thing. I'm a relatively new speaker. I've been doing this for about a year. And so I still get shaky and nervous from doing this. So thank you already for being warm and friendly faces. And but Victor's been doing this for like 20 years, so you don't need to be nice to him about it. So do we have some technical friends who know that there's a problem with the slides right now?
There you are.
Aha! All right. Oh.
VMware appeared on a screen and that it shut down itself immediately.
Oh no. I'm a developer advocate for VMware. There we go. There we go. That's me on Twitter. I do some things too, just like Victor. We both do things. And
okay, there's a screen. Oh,
yeah.
I can do this, can.
Did you want to say something for the setup part?
No, just. No.
Okay.
You can go. I mean, you cannot go because you cannot see what's going on. But
yeah. So we're going to be talking about what is Kubernetes validating admission policy. And to understand that, we'll need to talk about what are Kubernetes controllers. But I'm just like trusting that the things are going to come onto the screen.
There we go. Talk fast before it disappears. Go.
So to talk about what are Kubernetes admission controllers, we're going to talk about what happens when you create a resource with the Kubernetes API. So that's you or maybe some machine, and you've written a manifest and you want to apply it to the cluster to create a resource. The first thing that's going to happen is it's going to go through authentication and authorization layers. So who are you, and are you even allowed to make a resource here? Okay, you're allowed. So now we're going through our first set of admission controllers. The admission controllers at this point may have mutations. So what's going to happen is webhooks are sent through to controllers, and those controllers are going to look at your resource, and they may or may not decide to change things. So one thing that might get changed, maybe service mesh will be added. So maybe a container will be added to every pod. That might get changed, or perhaps a tool like Kyverno is going to change your manifest before it gets applied to the cluster. So what that might do, maybe it's going to look for CPU and memory, and if it's not there, it might add that. So look at our little manifest. Bam, it just changed a little bit because we had a mutating admission controller. So now it makes sense to go to the next step, which is object schema validation. So now the API is looking, does the resource you define, does it match the schema of the resource or custom resource of the cluster? If so, now we're finally seeing a validating admission controller. So as long as there's been admission controllers in Kubernetes, they've been leveraged to do validations. And so here's where policy can be implemented. So does it follow the policy that you've specified? And we'll talk more about that shortly. But assuming it does, it's still okay, that's when the resource finally gets written to etcd. And this whole process is going to go through again and again. Say we made a deployment. So now a replica set needs to get made, and it's going to go through this whole process. And then pods need to get made, and it's going to keep happening until there are actually resources running on the cluster. So that's how that goes. So what then is Kubernetes validating admission policy? So that validating admission controller step that was kind of done third-party tools, however they wanted to do it, now we have a standardized way to do it that's baked into Kubernetes. How am I doing, Victor? Do you feel good about everything?
If I would be listening, I would say you're doing great.
He has me tuned out. But that's because he trusts me, not because he doesn't care. It's a little bit of both. So here we have a validating admission policy. So this is now baked into Kubernetes. Ooh, you can see how badly I'm shaking from adrenaline by the way this. Thank you. So we've named this one demopolicy.example.com. And so what it's basically saying is it's looking for resources that match these rules. If you're creating or updating a deployment with the apps v1, then it's going to look at the expression. Is your replicas, is it less than or equal to 5? And so if it passes the expression, then you get to make your resource. If it doesn't pass the expression, then it's going to look at the failure policy. And so here we have it set to fail, but you could maybe just give a warning or something and not completely fail it. Now here we don't, if we make this resource, the problem is we don't know when to apply it. Like, do we want to apply it to every single resource or every single time this happens in the entire cluster? Probably not. So what needs to happen with a validating admission policy, it also needs to have a binding. So this is a validating admission policy binding, which says if the label environment is set to test, then we want to use that policy that we just defined. So, easy? Well, we'll say it's straightforward, at least, right? Does it work? So, to go more into let's talk about what is an application in Kubernetes. So, Victor's at the helm. Will you run these commands, please, friends?
Yes, I can. I'm perfectly capable to copy something. Look at me doing it. And run it in a terminal.
Yes.
There we go. I'm
Excellent.
very good at it.
So we're
I can copy even more than one command. For all of you interested.
So we're creating an application in Kubernetes, and now we want to see all of these resources. So all of these resources, when you create just a vanilla application in Kubernetes, you're getting a stateful set, replica set, deployment. We're getting pods. We talked about services, all of these things. So do we need to create an admission policy for every single one of these resources? I mean, it's pretty tedious. It's doable, but tedious. And then we take it back to our slides. Okay, great. Thanks. Oh, now there's a command to delete it.
There you go.
Okay, doable but tedious. So here we have our person. They want to create all these things, and they need to make a policy for every single one. So that's like, okay. But what happens when you want to add custom resources? Maybe you're using Argo CD for GitOps, and that's going to add custom resources. Maybe you're using Knative because you want your application to be able to scale to 0. Well, now you have more resources you're adding associated with Knative. Maybe you want Crossplane. I don't know why you'd want Crossplane.
Me neither.
Maybe you want Crossplane because you're managing resources that are external to Kubernetes, and you're managing them through Kubernetes with Crossplane, and you're going to create custom resources there. So now if we're getting the CRDs that are with our application, now look how many we have. Hundreds. And if you have more applications, thousands. There's so many. Are you meant to write a Kubernetes validating admission policy for every one of these? Now we're getting out of the realm of this isn't realistic. It's not only tedious, but in managing, making sure they're up to date, it's not a good idea. So that's that's one reason why should you be doing it is But the second reason, here's an illustration of having to manage all of that. And it's great to have I do like that you're managing everything through the control plane, even external resources. You have one place where everything is managed, but doing it as on a resource by resource base isn't realistic. So another reason why this is difficult is that Kubernetes doesn't have a concept of an application. There's not a way to link these resources together. So we're in our example, here's another very similar validating admission policy. So very similarly, we're going to create and update things, deployments or stateful sets. If that happens, then we have our rule, a replica must be less than or equal to 5, and then it's going to pass. But what if our replica set isn't defined in our deployment? What if it's defined in our HPA? So maybe we apply a deployment that has 0 replicas, and it matches this, so it goes through. And then slowly, as more and more traffic comes to our application, it scales. Days, months, weeks pass, and finally we're hitting our upper limit of 5 replicas. And then it starts to fail. And the failure, this is failing, and that message is actually going to the HPA, which is doing the job of scaling it. And then it's like, well, then your application is breaking and you don't know why. So because you can define your application maybe on your HPA, maybe you're using Keta, or maybe you're defining your replicas here, then it's not a good idea because there's not a way to tell Kubernetes, to give Kubernetes the context of the whole application. So what should we do? Victor, come in and save the day.
Okay, so what is happening more and more often is people creating custom resource definitions, right? Creating schemas or definitions that are at the right abstraction level of the people using it, right? So if you're a developer, right? Most of you here are very extremely familiar with Kubernetes and similar things. But if you're a developer, you want to have the right abstraction level and to say, this is how I define my application, right? I have something called application. I have something called database. And then all the low-level resources are being created by controllers in Kubernetes cluster that do things, right? And we do get those custom resource definitions either by installing third-party applications, like those that Whitney mentioned. Knative, for example, is a great example of how you can create the right level of abstraction to define what something is, in case of Knative serverless application typically, and then the low-level details are created by controller of that resource. Now, that's one way to go, right? And you're almost certainly going to do it through third-party applications, or you're going to create your own definitions of what something means in your organization. So here is a silly example. I defined a custom resource definition called upclaim that enables people in a company to define applications at the right level, at the level that they understand what it is. And in this case, it's just a couple of parameters that say, hey, this is going to run in production, this is the image, this is the port, this is the host, go, right? And behind the scenes, the controller will do the heavy lifting of creating ingress or services or virtual services or whatever else is required for such an application to run. Now, that's the simplification part that is unrelated with the policies we talked so far, right? How can we simplify lives of somebody? But it is also related to policies for 2 reasons. Because all of a sudden, developer or somebody who wants to have something is working on that abstraction level, not really interested in the low-level details, and that's the place where we can apply policies. Because if you apply policies for something called, in this case, example application, we have the context, right? Because that's the level of abstraction that creates all those low-level details. We know that there will be a deployment, an ingress and service HPA, whatever else there will be. We know what we have instead of having a potential mishmash of different resources. So I'm going to use Crossplane to show you this in action. And I'm using Crossplane mostly because I'm very, very familiar with Crossplane. And you can accomplish the same thing with many other ways, right? You can create your own controllers with meta controller. You can use cluster API. You can use kubevela, for example. So many, many different technologies. It's not about Crossplane, but more about figuring how to do that. So what I'm going to do is that I'm going to simulate that I'm a developer, and I want to create a I want to create a database, right? So, and to create a database, you need to figure out what's your provider. Is it Google, AWS, Azure? Do you have VPC, subnets, whatever you have, right? But I already have a CRD for that. So I'm going to just say, by the way, I'm going to use kubectl. Never, ever, 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 ever do this in production yourself. Use Argo CD or Flux, please. This is only for demo purposes. Don't say in public that Victor deploys to production like this. Anyways, SQL, AWS official, right? Here I have one definition. I created the database, right? I created a secret as well, unrelated with this talk. I created something called SQL claim. That's very easy for me.
Make it bigger.
Make it bigger. There we go. Is it big enough?
Yes.
Okay, cool, cool. Complain. So this is what I got, right? By creating that single resource, I got this, which is all the typical AWS stuff that nobody understands, but everybody has to use. Like, I created an instance of a database, database server, or I will create it soon. There is a database there, security group rules, security groups, route table associations, and so on and so forth, right? This is what the controller created behind the scenes, not something I created directly. Now, what really does matter is that if I would try to create policies for all of those resources and hundreds of others, that would be a disaster. So what we're doing is what I just did is essentially slightly different. Instead of creating all those resources separately, I said, hey, you cannot do any of those things. You can create something called SQL. That will create all those resources, and those resources will create stuff in AWS. Now, the important part here is for me to show you how all that works, and then I'm going to go back to the subject of policies, because that's the subject of this talk, right? So I created something called SQL claim. I use labels to define which we call it compositions, but you can call it otherwise, that I want to use AWS, I want Postgres database, I want some parameters like version 13, size small, because I have no idea what sizes AWS have, but the designer of this composition did include that part as well. So what I'm going to do now is to define you remember all those resources that were created behind, right? I'm trying to skip creation of policies for all those and concentrate only on the ones that people can instantiate. In this case, I'm saying, hey, I want to have a policy that says object called SQL claims or SQLs, if it has spec parameter size matches small, medium, large, then you're fine. If it has anything other than those three sizes, not good, you will fail, right? I bound it to all environments effectively. And then I have another policy that says, and by the way, those policies are introduced in Kubernetes 126. This is available. It's actually not available because it's still alpha, but you can enable it in Kubernetes, by the way. And another policy that says, hey, this one allows only medium and large sizes for your database servers. And the version of your SQL must be 1 and then followed by 3 or 4 dot whatever, right? Effectively versions 13 and 14. And then what I'm doing here is saying, hey, but this first policy that says it can be any of the three sizes, that is applied anywhere. But the second policy that restricts specific versions of the database and the specific sizes for the database server are applied only if the namespace has the label environment set to production, effectively only to production environments, right? And of course, I would have other policies. But what matters here is that I can concentrate when creating policies only on the user interface effectively instead of all the resources that are managed by my Kubernetes cluster, greatly simplifying my life and other people's lives. So let me apply that one, copy paste. And then if I deploy the same resources before, this is the same database like what I applied earlier, the one that worked, but this time I'm setting it to the namespace production 2. That's the only difference between what I did before and what I'm doing right now, and the output becomes thou shall not pass, meaning the size must be one of medium large. This definition, which I can show you, by the way, this definition says I want to use a small database, right? So what I'm trying to say here is that policies are baked in, admission controllers are baked into Kubernetes. You have a bunch of tools, and now you have even some implementation of the policy engine baked into Kubernetes. The piece missing over there is that if you try to define policies for everything that your Kubernetes cluster can do, you're probably extremely, extremely young. Because there's so many years left until retirement, and you will have enough time, maybe, to finish it. That's our very, very short talk. We like to keep it, I like to keep it short, so that we have a lot of time for questions. Go. Nothing. If you want to ask, you have a privilege to catch the microphone.
So why? Why are you doing this? I mean, tell me just kind of in just summarizing why is this relevant right now?
Why is it relevant to use policies, or?
Why is it what you're proposing relevant, or why is it what you're talking about relevant right now to people who are out here just trying to? I see what you're doing, but I'm trying to understand what it is you're trying to bring forward. What are you trying to provide here?
So there are a couple of things, right? First, that the only place that is reasonable from my perspective to create some kind of validation is on a server side, right? Traditionally, what we were doing in the past is, hey, you have some scripts running in CI/CD pipelines or something like that that will validate that what you want to do is something that you can do, which was always a horrible idea for a simple reason, because if you try to do validation somewhere on a client side, that means that you need to always go through all the tooling, all the places where that validation can be executed, right? Once we move that validation into the cluster, we have one place where we define what can and what cannot be done, right? Instead of chasing all the different places. Oh, can you execute it from your laptop? Yes, that's where I need to force you to use this script, right? Can you execute it from pipeline? Yes, we need to force you to execute this validation over there, right? So first step, moving validations that something is acceptable into Kubernetes, which Kubernetes itself gives us all the tooling, or at least gives us the webhooks called admission controllers that will trigger processes that validate something. And now we have the implementation of those webhooks apart from third-party tools like Verno, OPA Gatekeeper baked into Kubernetes, right? But once you start to do that, once you put validations in the right place, you're faced with the sheer volume of all the types of resources that might need validations, right? Because Kubernetes resources tend to be very, very low level, meaning there is no such thing as application in Kubernetes. It doesn't exist, right? So you need to create those abstractions, first of all, to simplify the user experience, because no Node.js developer really wants to deal with deployment, stateful sets, services, virtual services, ingresses, and what's or not. Second, more important for this talk, because once you create those right level of abstractions and deny access to the low-level resources, you have remote chance to define policies that actually do make sense. Does that answer your question?
Good enough for me.
Okay.
So, is this on? Yeah. So you said that these policies should be available in 126. So I'm curious, if we enabled it now, what are some of the rough edges to look out for if you wanted to use this in production?
So Kubernetes community project changed the way how things are done, in terms that in the past, we were having anything starting from alpha versions baked into Kubernetes core, right? Now that afterwards it changed, okay, once it reaches beta, it comes into Kubernetes. Now it's once it reaches V1, it goes into Kubernetes. That means that now we are in alpha stage with admission policies, the implementation in Kubernetes means that it is not baked into Kubernetes yet. You need to enable alpha feature. Now, depending on which Kubernetes provider you're using, that's one way to do it, or no, or you cannot do it at all. Now, the major problem, from what I've seen, there are no major issues in terms of how it works that I know. The major issue is that there is a strong chance that the API will change, right? That's on one hand. So if you would start using it right now, you might need to rewrite part of your things. On the other hand, if you already have policies, great. Use whichever policies you have. On the other hand, if you don't have policies right now, if you would be starting implementing policies today for your cluster, then you would be in a tricky situation because you have to make a choice. Will you use something that is going to be baked into Kubernetes and that is going to be standard, but it's not production ready? Or will you use something that is production ready, but is likely going to be replaced fully by the API, not necessarily implementation that is now available, which is baked into Kubernetes. So if you start today, let's say that you use Kyverno. I mean, if you already use Kyverno, Kyverno is amazing, great, right? But if you would be starting today, will you write all your policies in a syntax that is likely going to disappear? Tough question, right? Or you use something that is not ready for production, even though you have production-ready options available.
Yeah.
Right? I cannot share much, but I know that at least one of the major policy providers right now, without naming them, is likely going to rewrite their engine to use the standard, call it standard, right? See, I feel that something on a much smaller scale will be happening with policies as what is happening with observability, that now everybody is going in a direction, okay, so I do need to support OpenTelemetry, no matter what I had in the past and what my format was. I expect the same thing will happen with policies. And that means that OPA, anybody likes Rego? Okay. Then you're going to have a hard time. Careful. Like, that's unrewritable to this. Sorry. Anybody else? There we go.
So how's this going to change the developer's experience? What's going to, or not at all?
So depends. If the question goes towards CRDs or policies, or both?
Both. I mean, the developer, it's going to be transparent, I'm assuming, right? Or
yeah,
what's going to
change? CRDs themselves, I think, are transforming developer experience to be much better simply because what we have in Kubernetes and what we have in cloud providers, from my perspective, is too low level. It's not the right level of abstraction. Find me a developer who understands how to create an EKS cluster. Because those of you not familiar with EKS cluster, all you have to do is to create an EKS cluster, nodes, internet gateway, subnets, VPCs, madness, right? It's not the right level of abstraction. So CRDs are going to simplify that and allow developers to do something that is tailor-made for their needs. Now, policies are also simplifying because actually, it depends how you look at it, right? I see policies, first of all, as implementation of good practices. You get immediate feedback. This is okay. This is not okay. I'm very much against forcing people to read some wiki page that will tell them, execute this script, and then that script will tell you whether that's okay or no. This is very straightforward. You have a development cluster. You want to push something there. It tells you, no, this is wrong, right? It gives immediate feedback, and that's a good thing, I believe.
How does this differ from OPA?
I know it's in a practical sense, it's not different from no, sorry. End user experience is not different, right? Somebody defined policies, right? You try to apply something, and the policies return to you with saying no way, right? Now, from the designer perspective, from somebody who designs policies, there is that same question that I was asking before. Okay, so if there is something baked into Kubernetes as a standard, does it make sense for you to use that or to use some third-party, very specific solution? Doesn't matter whether it's OPA or something else. I have a slight beef with OPA when within Kubernetes. I think that it could do better being more kube native and playing nicely with other tools, but that's my personal beef. From the end user perspective, it's the same. You get the feedback whether that's something okay or no.
Okay, thanks.
I have 1 minute left. They tell me. Anybody else? Last question. Yeah, yell. I cannot speak for Caverno, I promised. But if you see them in a KubeCon, they'll probably maybe be open to tell you about the plans. So Caverno, but let's put it this way, right? Tools like Caverno that are, so the validation policies that are now in Kubernetes are basically a declarative way to define policies with exception of having expression field that is using cell, which I don't know what it's short for.
Common expression language.
Right, and it would be relatively straightforward to transform syntax of something like Caverno into that. It's different YAML, essentially, right? And Caverno also has something similar to cell. So it's likely going to happen. And it will really depend on the pressure that comes. If something similar to OpenTelemetry happens, in meaning that the user starts pressuring vendors that, hey, I like what you have, but I want you to compete on top of this instead of being completely separate, then we'll get it, yeah. I would ask anybody else, but I will be kicked out of the stage. She will not be kicked out. They like her, but I will. So thank you so much. See you around.
Thanks.
So, would you mind sitting down for me? So, good morning. Good morning. Apparently, we've to start. So, if you could sit or leave or do whatever you're kind of doing, please. Brilliant. Thank you. So, I'm waiting for them to hit my slides, and then I know I'm starting. There we go. So good morning, everybody. I'm Amanda Brock. I'm the CEO of Open UK, and it's really lovely to be back here in Amsterdam, a city that I used to call my home. Lived here for a couple of years, a few years ago. I started my journey in open source 15 years ago, almost exactly, when I joined Canonical. I was a lawyer for 15 years, and I joined Canonical as the general counsel, the head lawyer, and I ran the legal team there for 5 years. Since I left Canonical, I've had a number of different roles around open source. One of my favorites was chairing an advisory board for the UN. I've also got a role with the Open Standards Board in the UK. Open source software is under, for some reason, standards in the UK. And I'm an elected board member to the Open Source Initiative. Last year, we published this book. It has my name on the front as I'm the editor. It's got 26 authors, 24 chapters. It's also known as the fucking book because the fucking book took my holiday away last year. But it got published and it filled a gap. And it filled a gap in the market where there was no real explanation of law, policy and practice across the board that was up to date. Now, because we started it 5 years ago, it doesn't cover AI. And that's really frustrating. You know, all the content was into edit about a year before the book came out. So look out for something on AI coming your way relatively soon. The little flyer is not necessarily to encourage you to buy it, but if you do buy it, there's a 30% off code on the flyer, and you can get it free on download as an open access book sponsored by the Veach Foundation. You can find that on the OUP website, but it's really easy to find on amandabrock.com. We launched with a panel session with some of the female authors at All Things Open last year. And bizarrely, that went viral on the Chinese internet. So we now have a Mandarin translation that will be in publication by October. And I spend a lot of my time doing stuff like this, sort of wandering around talking to people in rooms in different countries. So at Open UK, I want to talk to you just for a few minutes about Open UK, because my topic today is Will Open Source Fail? And the work we do at Open UK is very relevant to that. So we were set up in 2019, and we've sort of broken the model on country organizations for open technology. First thing we did was we brought together the three opens: open source software, open hardware, open data. And those are what we define as open technology. We think everything will fall under that. And we look to create UK leadership, but also global collaboration, which is hugely important. We have 2 full-time staff. We're recruiting currently for a community manager, a 3rd member of staff. But most of the team are pro bono volunteers. We run the organization like an open source project in many ways. You'll recognize some of these people. A number of them are speaking at KubeCon this week. And Hannah Foxwell, who is one of our ambassadors, is doing a lightning talk today at 5:30. So we've got about 130 to 150 people at any point in time who are really active in the organization and who bring the work that we do to life. We have a number of advisory boards who help us with the technical side of things. And we have an AI and a quantum advisory board that we're currently setting up and looking for people to be part of. So you'll notice quite a diverse organization, and we really try to create a sense of belonging in what we do. We had a conference, our first annual conference in February. We had about 800 people there, 7th and 8th of February. We had 88.3% of the people who signed up turn up. And I've just put that figure in because it's kind of incredible. I still haven't quite worked out how we got that to happen. But this is a little bit about who was there. So the speakers were really unusual. They were really unusual in that nobody pays to be on a stage with us, and they never will. But also, if you look at the makeup, it was 57.4% male. So almost half the speakers weren't male. If you look at the ethnicity, 76% white, not brilliant. But then if you go to our delegates, and this is something that I take great pride in, about 1/3 of the delegates were women. Now that's a little bit more than the tech average, but it's a lot more than the open source average. And if you look at the ethnicity, 50.3% white. So almost half of the people who turned up at our conference weren't white. And I think that must be almost unheard of in tech, let alone in open source. So we're trying to build a diverse and inclusive organization. And I have to say the work that Cloud Native has done has made that helpful, has made that easier for us. Partly because the focus on bringing in younger people, bringing in a real mix and diverse audience to Cloud Native has allowed us to pick up on the Kubernetes community in the UK, which is really thriving.
And these are some of the people, the companies that sponsor us and make this possible. Now, we work on 3 pillars. We work on community, which is about bringing people together, and we do that through things like awards, through an honours list, and we now have meetups. Our next meetup in London, if anyone is around, is on the 26th of April, and we're starting those across the UK. Hannah's going to be running them in Yorkshire, we'll have them in Bristol, we'll have them in Birmingham, have them in Scotland. So if anybody's based in the UK, you're very welcome to come along. Wherever possible, what we do is free, and we use the sponsorship money to cover the costs and the overhead, which is why we have a small staff. We keep the staff costs down, and we flex on contractors when we need them. And we use the collective voice that this organisation gives us to influence laws and policies, and that's going to be really important as we go through this presentation. So we responded to the Supreme Court, to the Oracle Google litigation. We joined an open source amicus brief. And we responded to NTIA on the S-bombs when the Biden administration produced the executive order on that, which I'll talk more about. We've also worked to pull together reporting to demonstrate the value of open source in our country to our public sector, to our government, and to enterprise. And with these 3 phases in the first year, we very much did a literature review. We looked at what was out there. We cut the existing data to demonstrate it for the UK. We then evolved through doing a survey. We repeat that every May, so we'll be doing our next survey this May. And the survey gives us data that can be built into economic modelling. And then in the third phase, we were going to COP26, so we started to look at the values and sustainability, the broader picture. We did something similar last year, and we keep trying to evolve this piece looking at the value of open source, the economic value. And it's going to be critical that we as a community, we as businesses, we as enterprise can demonstrate this to our governments. If you look at the top left there, we showed 4.87 to 6.65 billion in investment in the UK in open source. And that's time. That's the measure of time committed by UK organisations to open source. It's 5 times the amount of money that the government put into the Recovery Fund for Digital in the UK in the same year. So it gives you an idea of the strength and the importance of open source in our economy. And all of this is online. It's all Creative Commons. You're welcome to take it, do what you want with it, attribute us, please. But it's all on OpenUK/State of Open. We hope to have a phase 1 for 2023 published in this coming week, and then we'll have 3 more phases. So we're going to do a 4-phase report this year because we have an election in a year, and we've got a lot of messaging that we want politicians to hear. We were very involved in setting the agenda around sustainability and open technology. In 2021, we were at COP26 in Glasgow. We had one of the biggest tech events with a couple of hundred people there. And we have a free-to-attend event in September, on the 14th of September in Edinburgh. If anybody can make it, you'd be very welcome to join us. We released this blueprint for a data centre of the future, reducing carbon emissions and creating a more sustainable environment using open technology. A lot of that depends on containerization and cloud native. And this was released at COP26. This year, we've done a similar one on electric vehicles. And the intention now is those are going up on GitHub, and we will be building communities of contributors across the globe to participate in that. Security is high on the agenda. We launched our first summer of open source software security last summer. We did a number of webinars, podcasts, different bits and pieces. That was noted as one of the 8 initiatives in 2022 that was important in security, and we'll be doing a second one this summer. But our third pillar, so we have this community. We bring the leadership together to give it a voice. We use that voice to influence law and policy, and then we develop skills and learning, and that's building the community of the future. We started with kids camps. We did 2, and we got the runner-up prize in the GNOME Community Challenge. Last year, we did these webinars on future founders, and they're very much about running a business in open source, how you generate revenue and income, how you build products. We did something similar at our conference, and the video from that is going to be used within a MOOC, a massive open online course with Strathclyde University, which will launch later this year. Hopefully, we will have sponsorship, and that'll be free for anyone anywhere in the world to participate in. But it's going to teach skills that are needed beyond pure engineering to build open source businesses. Give you a little bit of an idea of our scale. You know, I told you we had 2 employees. But this is our 2021 MUV. And MUV is the way that you recognize press presence. monthly unique visitors. It doesn't mean this many people looked at our article or clicked through. It means the articles we had and the publications they were in, this is our aggregate. And we punch way above our weight. And we do that because we're a collective. We're based on all of the people who lead within the UK. This is our Twitter impact last year. We average now, the honours list gets us, as you'll see, the honours list is a very British thing, but it gets us a huge traction. Year one, it was around 400,000 impressions on one tweet. Year two, with NextGen, it was around 150, and this year it's around 250,000 again. So if we take that out, we're now averaging 100,000 impressions a month on the Open UK Twitter account, despite everything that's happened on Twitter, despite what Ellen's done. And, you know, Mastodon's rise. But Mastodon doesn't really work in the same way, so it's hard for us to give you realistic stats. What we have seen is a bit of a rise in LinkedIn. I mentioned State of OpenCon, our first annual conference. We will be doing our second either on the 31st of January, 1st of February, or 6th, 7th of February. We're just waiting for the venue to be confirmed, and we've got two possibilities. It won't be the same place as last time. So all of this is about open source. Why does it matter? Well, and what is it? For me, open source can be simply defined if you're doing it for a contract. And it's source code where the source is freely available and it's distributed on an open source initiative approved, an OSI approved license. And that second bit to me is really important. So this is the OSD, the open source definition. I couldn't tell you what the 10 terms are, and I can almost guarantee you that nobody in this room can. I doubt if any member of the OSI board could even recite them. For me, the two really important definitions are 5 and 6. No discrimination against persons or groups, i.e. everybody anywhere in the world can use open source and participate in it any point in time. Second one, no discrimination against fields of endeavour. Doesn't matter what you do with it, you will not be stopped from doing it. There's no moral judgment, there's no ethical judgment, there's no division geographically. And these are at the very heart of what makes open source open source. Without those, you might share your code, you might have public source, but you're not going to meet the standard to be an OSI-approved license, and you're not open source. And you're probably wondering what all of this has got to do with Kubernetes and Cloud Native, but we'll get there. One thing all of the licenses that the OSI approves have in common is that they disclaim liability, to use a lawyer's term. So they say that I'm not liable. I'm a developer, I've created code, I'm giving it to you free of charge, to the extent that the law allows me to disclaim liability, to say that I'm not liable, I'm not liable. You might recognize it, it's the MIT license, a very permissive, commonly used license. These three clauses come from GPL3 and these from Apache 2.0. All say much the same thing. I'm not liable. If you take my code and you use it in an environment, you, the end user, have made that choice and it's up to you to manage it. So when I started in all of this at Canonical, it was really hard. And it was really hard because nobody in big companies would use our code. We were banging on doors and we were trying to get into those companies and we couldn't get in. And we couldn't get in because we had this risk-averse block. And the risk-averse block was procurement, it was finance, and it was legal. They didn't necessarily understand open source well, but they understood how to stop things happening in their companies. And there's been a shift in the last decade, particularly the last 5 years. And that shift has come through a number of different things. I think the primary shift is digitalization, right? So the role that you all play as engineers has been elevated. The role that engineers have in every company, not just tech companies, is much more important. I know the last few months and the layoffs may not make people feel important, and I know people are worried about salaries. But with digitalization, every business needs engineers. Every business uses software. It either creates, distributes, or has its products consumed using it, and there's no way around it. So the engineers have become the decision makers. And if you combine that with the sort of escalation we've seen around the usage of Git through the public repos, through distributed code collaboration, you see a time when you can go to GitHub, you can take a package and you can bring it into a big commercial entity without going through legal, procurement, or finance, so they can't block it anymore. So it's no longer a question of contract. The contract that you have for that code is the open source license. That's where your rights come from. You don't need a contract. It shouldn't be mentioned in the contract. And if you're mentioning it in a contract, you're creating problems for yourself. You might say we're using XYZ, but don't try and license it in a commercial contract. So what you see is you can take the code into your organization and use it, and you only have to go to legal, finance, or procurement for approvals or contracts when you get to a stage of buying something like support. And generally, we don't do that at the same time as we start to use the code. The third thing that's had the impact is something, and this is a really out-of-date slide. This is, I think, the last slide from when Dan Cohen was running this. What you see is that the cloud has really shifted open source, because the cloud's built on open source, right? You're here in Amsterdam, many of you for Cloud Native, you know this. Microsoft, when I joined Canonical, was bug zero. The destruction of Microsoft was one of our goals. Things shifted. By 2018, Microsoft was on a journey. They were talking about their journey publicly. Today, they're the biggest single contributor to open source, according to the stats. And this is Steve Wally, a mate of mine, keynoting the Open Source Summit in Edinburgh in 2018. And he explains Microsoft's journey as three things. First of all, developers who've learned to code in the last sort of 20, 30 years all use open source. It's just the way people do it. It's the practical, sensible way to code. Secondly, innovation in open source has been way ahead of the curve. And it means that many products are only available open source. Many packages are only available open source initially. So customers specifically ask Microsoft for it. And the third thing is Azure. You can't run a cloud business without not just using, but engaging with open source. You can't just use, you have to give back. You have to be part of the community. You have to have influence. You have to contribute. And we're seeing that spread. We're seeing it spread through different sectors, different verticals. Automotive has been a big one. This year, mobile is really in the public glare. Companies like Rakuten using Kubernetes, GSMA announcing their APIs. And we also see it in the public sector. In the UK in 2012, we were one of the first countries in the world to have an open source first strategy, policy. Lacked a lot of procedures behind it, and it lacked teeth, so we didn't have anything to sort of hold them to when they didn't. 2019, we see Europe starting to talk about their digital decade. 2020, we see the COVID apps, but it's not just the apps, it's the back end too. And we see the NHS and the energy sector in the UK positively shifting for their national infrastructure. So think about it. The work you do, the contributions you make, become part of something that is actually the national infrastructure for our enterprises, for our public sector, and our critical national infrastructure. So open source is one, right? The battles that I was in at Canonical, Microsoft's on board. We're now the dominant way to code. 48 to 98% of code is built open source today. So now what? Well, we used to talk about FUD, fear, uncertainty, and doubt, and we used to accuse Microsoft of spreading it. Today, we still have FUD, but it's a different kind of FUD. It's a different kind of confusion. During lockdown in 2020, we saw some stuff from people who should know better. Big cloud companies are free. Think back to the open source definition. They're free to use open source software, and they're free to use it as they wish. They can use it commercially. Definitions 5 and 6 of the open source definition. Should you choose to open source your software, they can use it. But what we saw was this got as far as the New York Times, talking about the fact they were strip mining. Now, strip mining is a New York term, a New York legal term, and it's used where, or it was used in the 70s for coal mining, where you over-mined the coal and you left nothing behind. And that's what a number of open source companies were accusing Amazon of doing. And then we saw this from Shay Bannon, the founder at Elastic, where he was doubling down on open, except what he was actually doing was walking away from open. He was moving to the SSPL, which is not an OSI-approved license because it doesn't meet the definition. That and the Commons Clause, a bit disingenuous, implying that they're open source when they're not, and causing a lot of confusion amongst engineers, understandably. Very, very understandably. But this is very definitely FUD. And it's still going on. We see Lightbend and Akka last year. Interesting attack that we're now seeing. I mentioned the mobile sector is a massive adopter at the moment. And we're seeing a problem with the standards bodies. So we have Etsy, who are in the Nice area in the south of France. If you're part of this, you go down there a few times a year. It's a very nice trip. And you get to go and set standards. And those standards tend to be based on FRAND. Fair, reasonable, and non-discriminatory. But what they do is they charge you for patents because they have standard essential patents, SEPs. And SEPs have a royalty charge that is fair, reasonable, and non-discriminatory, but it is a royalty. So what they're trying to do is make that flow with open source, and the two are in friction because our ecosystem needs to be free to move. And we've seen organizations like 4IP and some of the telcos who have a lot of money, right? Telco's 40 years old, it's relatively immature, it's lost a lot of its revenue with things like roaming charges being taken away, things like the OTTs going over the top with WhatsApp. So what we're seeing is telcos actively trying to redefine open source. Now, open source to me is much more than that legal definition, right? It's having a community, it's having collaboration, it's having contribution, it's having good documentation, maintenance, plans for the future. I could go on. It's all of those things, but that legal definition with the OSI-approved license has to be at the heart, or we allow people to undermine. And that's what these people are trying to do. They're trying to say that we have 300-400 licenses, many that aren't OSI approved, that are open source, to allow them to create open source, but with my patents. And it just doesn't work. Don't take my word for it. In the fucking book, there is a chapter by Knut Blind from Fraunhofer talking about exactly that, picking up on the work that they did for the European Commission in this area and explaining that the two are just in friction and don't work together. So what we need is we need open standards that everybody can freely use without patents. And bear in mind, 70% of those mobile patents are held by 7 companies, and they turn over billions of dollars a year on those patents. We could also, where they have SEPs, standard essential patents, work with defensive patent pools like OIN, and that's not new. We saw that done in 2014 with the, or 2012 actually, with the Rockstar Patent Consortium. Another problem we're facing is geopolitical shift. You wouldn't really think international politics would be affecting open source, right? But it is hugely. So we see this letter from Ursula von der Leyen, rather, appointing Marguerite Vestager as the VP for Digital in Europe. And you see her talking about major shifts in the way from global power structures to local politics. Then you see Brexit. This was at FOSDEM in 2020. We were outside the Commission when we Brexited and they turned the lights off on us, and it's been pretty much the same since. So I don't want to sound like a drama queen, but only last week I was having a conversation with one of the directors of a European equivalent of ours. And I said to him, you know, it can be hard because things that we used to be part of, we used to engage with, it sort of feels like we're not wanted post-Brexit. He said, oh, no, you're not wanted. The Commission has told us not to bring you in. We don't want the UK there. We don't want UK speakers. We don't want Open UK. That's not open source, my friends. Open source is for everybody. Doesn't matter whether you're from China, the US, the UK, or Europe. It's about us collaborating on a global basis. And we have these problems globally. It's not just with Brexit and the UK. We have it between the European Union and the US. We have it between the EU and China. We have it between the US and China. We have it between the UK and China, where there are discussions about excluding contributors, wanting to know if anybody's from China who's contributed. And it's not just on the political level. You know, the ultimate geopolitical shift has to be war. And that doesn't just affect us in that way, it also affects us with things like protestware. Now go back to my definitions 5 and 6 of the open source definition. Definition 6, any purpose. We can't restrict any people, the Russians, from using open source, heartbreaking as it is to watch what's been going on in Ukraine. And then we see the infrastructure that I talked to you about being attacked. And we see it attacked because with digitalization, we're sitting at a point in time where governments are more concerned about technology than they ever have been, maybe rightly. They're concerned about software. They're concerned about software security. And in being concerned about that, we see the requirement for SBOMs. We see the reaction to Log4j, a plan between the OpenSSF and the US government and many companies to start to roll out fixing the perceived problems and the real problems around software security. Now, the first thing I would always say if software security comes up as a topic is that it's a software problem, not an open source one. We just happen to have our own nuances, and we wash our dirty linen in public, so it is very, very clear and transparent when we have problems. But we also have a collective response. But what we're seeing here, only last month from the Biden administration, is a shift, and a shift to making the commercial distributors responsible for the code they distribute. Now, I talked to you before about the importance of the end user responsibility for the situation they choose to use it in. They try to call out, and they've done their best, I think, that they could, and I've highlighted this here, open source and the fact that developers should not be liable. But that's going to require quite a lot of education as this becomes law, and making sure we understand how to keep our licenses away from our commercial agreements, because software that's freely distributed without a payment will not incur this liability. And we're going to have to be really clear about it. Here in Europe, we've got the Cyber Resilience Act, completely different flavour to the same kind of regulation. Massive outcry from the open source community, complete lack of understanding of what open source is and the open source definition. There's, on the right-hand side here, this page will take you through to 40 organisations' responses to it. Recital 10 talks about commercial open source. No such thing. The Americans get it right. They talk about open source being distributed commercially and paid for. Open source is free for anyone to use, whether they're in a company or not. It's free for anyone to contribute to, whether they're in a company or not. No such thing as commercial open source. There is just open source. They also start to talk about product liability, and they make software subject to liability even if it's not embedded. And the fines for non-compliance are pretty high, as you can see. They're also looking at having some sort of audit from a department or an organization like Senelec, some sort of standards body telling you how to code and to check that code meets the required standards. The last meeting I was allowed to go to, and I wasn't allowed to speak at in the Commission, was in 2019. And at that meeting, they suggested that we ought to certify developers if they were going to code. So I responded, and I think it's the best applause from the smallest audience I've ever had, and it's probably in a recording somewhere, but they really don't like me. Product Liability Directive is really avert about what they're trying to do to software and the liability they're trying to put in there. There's a lot of detail in here. You can look at the slides, if you want to afterwards. It's been a lot of work in the UK, but through the kind of reporting we've done and the engagement we've been able to have with the public sector, with the policymakers, we've got some decent recognition in our consultation around open source and its position in the ecosystem, the fact that proprietary code uses it as well, the fact that proprietary software is built in open source languages. And we see a recognition of the value of the software, the open source software community and what it brings, and a desire not to place burden on it. Now, the next step for us is getting this translated into law that makes sense for open source in the UK. The consultation ends in May. We'll be publishing something in advance and encouraging others to submit too. They're also trying to work in the international context. I don't know if their experience is any better than mine, but maybe it is. So, state of open. Open source is one, but is it sustainable? Nice piece in the news stack after our conference. I think there's three key things that we, all of you, need to be thinking about. And the first is curation. Term Eric Brewer at Google came up with. He wrote this piece in our State of Open report last year. Curation, to me, is the good technical hygiene that you're all talking about this week at KubeCon, the sort of processes and procedures that they were talking about in the last talk, and the good governance and the understanding of how you do open source from day one. And we need to see enterprises and the public sector starting to curate open source properly, not just sticking it into their organization and wondering what they've done. We need to see them start to build, particularly in the public sector, an understanding that open source is more than that legal definition. They want to avoid lock-in. They want to create code that's recycled and reused. It has to be developed in the open. It has to have community around it. It has to have contribution and plans for the future, not just a fly past on GitHub throwing it over the wall. That requires government and the public sector to build an understanding of open source. You've seen what happens with the Cyber Resilience Act when they don't and they get things wrong. But also, I think it needs a step further. We need to start to see open source and the infrastructure. I explain it to them as a pizza. They don't necessarily, when you start talking to policymakers, understand technology and open source. And I always say the toppings are like all the things that people want to talk about, whether that's the cloud, the internet, ML, blockchain, AI, whatever it is. Those are the toppings that you put there that you all have your view on. And sitting underneath it is a base that most people are not interested in, and that's open source. We need them to understand that that base is there. We need them to invest in it properly, to consider it as a digital public good. We also need, as a community, to start to demonstrate our value and speak up more. We need to show that value. I've put one set of infographics up from 2022 already. These are our 2021. We used the formula the Commission had to demonstrate 43.15 billion of contribution to GDP in the UK from open source. We worked with an economist from the UK Office of National Statistics to move this a bit further, and we got us 46.5 billion. We're currently working on what questions to ask for a survey this year to see how we can make that work better, because these figures were based on around 250,000 developers in the UK. I think I'm proud to say that GitHub has told us in January that we're over 3 million now. The nearest in Europe is Germany at 2.1 million. 4.5% of the UK population now has a GitHub account, and our goal is to double or treble that, because that's the way that you measure open source developers. It's not accurate, but it's what we're stuck with. If anybody's got a better idea, please talk to me. So this is how you contact me or Open UK or follow us. Really keen to talk to people, whether they're in the UK or anywhere else. And thank you very much for your time. Will open source fail? Andy put a bet on LinkedIn that my answer was going to be no. I'm afraid my answer to will open source fail is maybe. And I have one copy of the fucking book. If anybody would like it, means I don't have to carry it home with me. So whoever wants it can have it if they do. Thank you. Oh, you wanted to question? Am I allowed? I think I've probably over time, but yeah, sure, for me. I can't even see. I haven't got my specs on. If you might need to push that on.
Hello, hello. Yeah. I wonder why you might. Well, you're not involved, but could you maybe make us understand why Grafana choose to go for GPL?
AGPL. They went
AGPL.
Yeah.
Well, but that's not an MIT, not a CNCF anyway promoted license. What made them go? I have the feeling that's more of a European thing. Although
no, it's not. It's a global thing, and it's all about revenue generation and protecting your revenue. It's the same conversation that we had with both Elastic and Mongo, and that's shifting to SSPL. And Grafana very much learned from what had gone wrong with Elastic, and Shay Bannon's doubling down on open and moved to SSPL, and they wanted to stay within an OSI-approved license. And AGPL is the best way that you can try and protect code that isn't distributed, because a lot of the provisions in copyleft require distribution before they kick in. And AGPL it was structured to try and protect the developers a bit more. So that's why they went to AGPL. Any more? Oh, God, loads. Okay. Go to the back first. Oh, I have to give you the mic. Hang on.
Yeah, go ahead.
Oh, I've gone the wrong way. There you go. It's on.
Thank you. Bit of a side question.
Yeah.
But what do you make of OpenAI, which is, started as open?
Yeah.
And it's clearly not open.
Yeah. So.
Thank you. That was my question.
Yeah. I don't know why I'm using that. I was purposely avoiding AI for a long time because it is very difficult, right? And it's very hard to have the answers to it. What I make of OpenAI is that I would like it to be open, but clearly they've shifted their model and they're making a lot of money now. And they're making a lot of money from a few companies and very cleverly. But what we've seen is a massive response. And on OpenUK's Twitter account, whenever I see any open equivalents, I push the information out on it. And I think we all need to sort of follow that and try and engage with it. I'm more sad that we didn't do anything about AI in the book, because 5 years ago it wasn't relevant to open source in the way it is today. But we need collectively to really sit down and work this out. The OSI did something called Deep Dive AI. They did a series of podcasts and a report earlier this year. And there's going to be a lot more coming. The Commission, there's a piece in the FT, I think yesterday, about the Commission regulating how you code. And what they're talking about is copyright and respecting copyright, which could actually be good for open source. But at the same time, it's going to make it harder to... You're going to have to list out the copyright that you've used to train the AI. I mean, that's massive. It's going to be almost impossible to do. And if you're a small provider trying to compete with the likes of OpenAI, it's going to be really difficult. I have tried to talk to my almost namesake, Greg Brockman, at OpenAI, and I've not been able to get to him. The only person I know that knows them is James Governor, and he couldn't get a response. So if anybody happens to know them and would like to introduce me, I'd love to talk to them. Alex, there you go.
No, I was going to say,
okay.
What about Microsoft?
What about Microsoft and all this? Yeah. I think you should ask Microsoft for comment on that as the #1 contributor to open source in the world.
But as an open source organization,
I would like to think that they're going to open up their AI. But I think you should ask them.
Yep. You mentioned that GovUK had adopted an open first policy.
Yeah.
And some countries, I don't think they have official ones, but like some municipalities in Germany use a lot of open source. In Norway, I know a lot of the state-owned things publish everything. Do you have any like success stories that have come out of it, even though you said it was without teeth?
There's loads and loads. Last year, I interviewed 15 organisations for the NHS and the public sector, and they used case studies from it. The problem is, and this is a universal problem, not a UK problem, they use that legal definition, right? So they say, we've got a couple of million to give away to open source organisations. For five of you will get 400,000 each or whatever it is. And everybody applies. And the open source organisations are less used to doing this and don't sell so well. So organisations that have been proprietary often win that money. And what they have to do to be open source is to publish the code on GitHub with an open source license. That legal definition I went back to. I've been mentoring some of them for the UK, and it's been heartbreaking. So I've been talking to them about contribution, about community, about developing in the open, and almost without exception, the projects I've been mentoring, while they're really interested in open source, are doing a fly past. They're throwing it over the wall and they're leaving it, and nobody but them is ever going to touch it because it's going to be abandoned code on GitHub. So one of the things that I'm trying to persuade the UK to shift to is to have a list of requirements around developing in the open, around the code having to have a community and take contributions, or at least a community manager trying to work on that. So there are success stories, but they're not successful enough because they're not required to be, if that makes sense. And we need to do, and it's everywhere in the world, and we need to do a lot more work. And I think the story for government is that they shift to open source on a cost basis generally, right? It's the wrong reason, but it's usually #1. And they do it to avoid lock-in, and they do it to create code that's recycled and renewed. So when I asked one of those companies how they were going to maintain the code, they told me they had a 3-year contract. And I'm like, that's not open source, you know? So we need to get that moving so that they avoid that lock-in and so that they do create code that people will want to reuse. I think we're probably just about out of time. Was there one more very quickly? Very, very quickly.
Sorry, this might be a quick question, forgive me, but the Cyber Resilience Act.
Yeah.
And I would say that it looks kind of scary.
Yeah.
And we're looking at possible mandates and regulation, et cetera. And this is a huge issue, but I guess what's the status of that? I can do that.
Yeah. So
the Biden administration, it's my understanding, but probably being naive, but they're proposing recommendations more so, and they haven't spoke, for example, different things, SBOMs, for example, how they're implemented, et cetera. Or are they arguably pushing through scary things?
What they've said is, so with the CRA, the consultation finished in January. There was a lot of confusion about the date. It kept changing. A lot of people missed the date. But there are 40 organizations who are listed out on the OSI website who responded. And you can see the problems with it there. I don't believe the European Commission can go ahead with it in that format. I mean, you just cannot have the recital they've got that redefines open source. You know, it's just wrong. And they have an OSPO, so you would really hope that they would, you know, be able to work with them and improve it. In the US and in the UK, both governments have said that they're going to work with industry. But that means that we need the support of all of the people in this room and many more as the policy organisations that are trying to lobby, that are trying to get government attention going forwards. And we need to see those sort of collective voices in every country pushing to make sure that open source is properly protected.
Can we follow up?
Yeah. No, they really want me to go. Thank you very much. I really appreciate your questions.
Yeah. Hi, and welcome to my talk, GitOps Fail Repeat Lessons Learned from Running a Heterogeneous Platform. I'm going to go over the introduction. I'm also going to explain to you what our platform actually is and why it's not homogeneous, how we started and where we actually ended up and what we're looking forward to doing next. So, I'm Max. When SRE engineer, whatever you want to call me, I work for DT. I currently live in Germany, in Ulm. I like to drink coffee. And if I publish the slides later, you can just click on the links to find me. From the company I work for, you probably know Telekom. I work for for Deutsche Telekom Technik, which is a subsidiary of Telekom Deutschland, so it's just Germany. And the Schiff, the project I work for, is a project mostly on the NT side. So we handle network technology workloads, so the 5G core, but not public-facing things like the customer portal. What is our platform? It's an internal GitOps-based Kubernetes cluster as a service platform, almost exclusively built using open source components. We're using Cluster API under the hood. We have a lot of clusters because we do multi-tenancy on a per cluster basis. We use GitOps for everything. We don't do manual actions at all. We have clusters that do all the management. We have edge clusters. Yeah. Let's skip it. Now it's my PC. So, what are our goals? We want to build reliable Kubernetes clusters with a well-defined API contract for our internal customers. So we're just internal only. We want to basically provide clusters for internal customers wherever we need them. Given our company structure, we have a lot of different things to cover, from core data centers to also edge sites. We want to present a mostly unified experience for all of our internal customers, so that they don't really need to care on which cluster and which environment they are. And we basically want to prevent them from building components on their own that should be unified. So we provide them, on top of just a Kubernetes cluster, a monitoring stack. We basically build a log shipping daemon that already collects all application logs, that you not just need to tell where to ship it to. We also do the complete ingress side. So you just basically just pop an application into the Kubernetes cluster, and that's the thing you manage. Everything else is managed by us. Our environment is quite diverse. So we have sites that have quite different networking architecture, where we just have layer 2 networks, so classical switches with VLANs. We have ones where we actually have BGP to the data center edge, for example. But we also have modern sites where we just have layer 3 and no layer 2, where everything is just BGP EVPN. We also have different underlying infrastructures. So we have vSphere on the one hand, and we also have bare metal clusters on the other hand. For storage, for example, we have very different storage providers. So we have vSphere CSI, we have Pure Storage, we have NetApp, and a few others, depending on which data center you're in. They have different feature sets, they have different CSI providers, and we all need to encapsulate that. And we also have a huge variance in what applications we actually have on our platform. We have small web apps that just basically do things like running a Node.js application to provide a UI for managed services or interact with backbone components. We have an Elasticsearch instance. This has multiple petabytes of storage. But we also have network-heavy applications like a 5G core that require a lot of custom modifications to the networking stack because they're a lot more complicated than just a singular network interface on a pod. We initially started in 2019 with a proof of concept of Cluster API on vSphere. In one data center, with one vCenter, still using Flux v1 at that point, with a very simple repository layout. Every cluster had its own repo. We just placed things there. Flux applied it, and it just worked. We mostly used upstream charts for everything, or built charts and upstreamed them if we needed to, and just had one YAML file for every cluster that just contained everything you wanted. But after we scaled, we found a few issues. We needed to introduce environments for people to actually test what we're doing, and for us to actually manage what we're doing and present customers with a good track of what we're delivering for them. So we now have dev for internal development, test for cross-checking internal development against tenants with a very bad SLA, so it's expected to break occasionally, reference for applications to actually do all of their testing, and production, which is literally what it sounds like. We also needed a way to basically name our clusters, because we have a lot of them by now. We also needed it to be human readable, because a lot of the systems in our company that clusters need to interact with are not fully automated, and people need to be able to understand what they're configuring. There isn't an API for everything that we have. We still were using one repository per cluster at that point. But we ran into issues. So after we scaled, we ended up with a load of Git repositories. Every repository needs permission management. You need to provide SSH keys as deploy tokens and all of that. We're using GitLab. GitLab has some API bugs, especially around deploy keys, so that was a bit annoying to automate. And it's quite the opposite of don't repeat yourself. We have shared secrets because of the underlying infrastructure. Rotating them was a pain because you needed to do that synchronized across like 20 different Git repositories. You need to make sure that you really went into every repository and did your upgrades, and automating Git repositories isn't that easy because you still need to open up merge requests everywhere, go over that, and scale. After that, we basically started to move everything into one repository. We used the cluster ID that I showed earlier to build a folder structure so that every cluster now has its own dedicated folder. And then we basically split out duplicated config into different trees. So we had one tree for the development environment, one for each site. We just separated them and merged them together using Helm value overrides. Looks roughly like this. So we have a customization for each cluster on the bottom left that contained both the customizations that applied everything else and also the config map for cluster-specific configuration. There's not only environment, there were a lot more stages in between, but basically you kept track of versions on an environment basis, and everything else just added to that configuration. It's not that easy to manage that. We figured that at some point we actually need to do staged rollouts. That was hard because everything basically shared one version, and as soon as you started to upgrade one environment, everything rolled. The number of config sources and permutations basically skyrocketed once we started to onboard more sites and figured out, oh, that's different here. We need to change configuration here, here, and here. Rolling that out was and managing that is really, really complicated because you need to know exactly where what is configured. And the number of people that actually were able to do that dropped off quite significantly because not everybody had the time to really follow up with what was added. Flux, in that time, we also migrated to Flux v2 from Flux v1, which was easier, but it was still very complicated. So after that, we basically started to look at different options. One of that was customize overlays. So basically trying to split as much into different customized files, which also wasn't working due to the complexity and number of changes that we have that are sometimes mutually exclusive. We also looked at tooling to just stamp out resources before committing that to Git. There's basically not good config management for any of that. We tried to basically use Puppeteer as a hierarchical database, but that also wasn't working that well. YTT was something we looked at, Helm subcharts, where we just basically discovered that subcharts in Helm are very, very broken, and you don't want to use them at all. Also, Argo CD, we threw that out mostly because of the architecture that we went with. We wanted to have fully self-sufficient clusters, where no cluster is reliant on a centralized environment to work. But we basically ended up with Helm as a config source, together with Flux. So we are now using Helm charts to manage Helm charts, but not using subcharts, but actually by stamping out Flux series, config maps, and secrets. That also gave us the option to use Helm hooks for example, running migrations. So if we now have a change in an upstream chart that we consume that is breaking, we can just basically run a Helm hook before upgrade and after upgrade to basically do all the necessary migration steps, like scaling down a deployment or deleting it so that the Helm upgrade doesn't fail. We now have versioned artifacts, which is also very nice. So I can literally just pin one cluster to one specific version and keep it there, and it will not change no matter what I do on other clusters. And if something breaks, I can easily roll back one cluster. And we also only have one config file now. So what we did is basically introduce params for having a unified input for configuring everything that is site-specific or provider-specific. That's the same for every component that we have. That exists one time per cluster in one config map and gets read by everything. We have it versioned, so if we ever need to do changes, we can just introduce a v2. All of that is validated by JSON, what's it called? By the JSON validation that Helm provides for values. So you can't even put in an invalid field, or if you added a new site and the version of that chart doesn't support it yet because it doesn't have configuration for it, you won't have an inconsistent behavior. Your apply will just fail and you need to grab a newer version. All of that functionality is built into a library chart. So it's not a subchart, it's a library chart called params. That chart also contains a lot of helper functions that we built for our hierarchy. So we now basically have a hierarchy tree in Helm values that you can use per component, where you can just basically build different feature flags and enable them. But if you ever need to change something in production, you can always just override everything on a per cluster level. You can also just introduce secrets on a per cluster level, and they will override everything else in the tree. So from an architecture perspective, it looks like that. So we just have one customization that applies a secret for secret values and a config map for the other values, gets reconciled by a component, in this case shift load balancing, for example, which is the component that we use for providing load balancing services. It mostly uses MetalLB under the hood, but for some environments also KubeVip. That then generates a config map and secrets consumed by the upstream MetalLB chart. That is also version pinned in that specific chart. So you can also just have a job that runs on migration. we needed to migrate our existing clusters to that approach. That was a bit painful, mostly because of Helm. Helm expects a few things, 2 annotations and 1 label, to be precise, on every resource it manages. We couldn't really apply that inside the GitOps loop. We then wrote tooling that basically iterated over every cluster, added those labels, then added our new component charts, and we then still needed to force upgrade Helm, so it actually started to overwrite values in cluster and roll out the exact things that we wanted. The cleanup of things that we didn't want afterwards was also quite easy because Flux already adds an annotation which Flux customization applied a resource or label which you can just filter by. So everything that is not owned by Helm at that point can just be deleted, and you have a clean class without orphaned resources. There are some caveats though. It's still very complex. So if you have an environment that is less complex, it's probably not worth for you to invest time building component charts to manage all of your stuff. Helm Go templates are still not ideal for a lot of things. They're hard to manage. Not everything is possible in a way that everybody can read it, let's call it that way. Template functions start to look ugly if you introduce a lot of values. And not all upstream components integrate well with that approach. So what I mean with that is basically if you have CRDs that are managed by an operator, and you want to also apply basically CRs out of that CRD in your component chart, you need to basically manually extract them from the operator if they're not published, apply them using Helm, and find a way that the operator actually doesn't manage them or really keep them in sync with the operator version. Our conclusions. Migrations are possible but painful, so if you can avoid them, avoid them. We never planned to be as complex as we are right now, because when we started, we really didn't know that our environment is as complex as it is. There is no good solution for everybody. What works for you will be different than what works for me. And we're currently adapting our charts to the Flux detection that is currently in beta with the Helm operator of Flux. Because that's basically the main downside that we had before, or with that components compared to customizations from Flux. They were not periodically reconciled. So the Helm chart was apply once, and that did, and only on an upgrade that was reapplied. But if you had drift in the meantime, that would never get automatically reconciled. There is a beta feature in Flux v2 now that fixes that. But there are some issues with some charts because they have weird interactions with operators, for example, and that breaks. And we're currently writing tooling to do rollout in a staged manner because we basically don't want to have upgrades on all clusters at the same time. We want to really stage that into smaller batches, validate things, and then ramp up like you have for example, with in-cluster upgrades. We want to do a rolling upgrade over our complete fleet of clusters. Questions?
So curious about rollouts that you talked about. So are you doing in-cluster upgrades, or you're creating a brand new cluster with a new version and migrating?
We are doing in-cluster upgrades. So the question was about our rollouts. We are doing in-cluster upgrades. We just basically there's a Helm release in Git for every cluster that we just up the version to the new chart. That's hopefully tested in dev and then hopefully tested in ref. So it's progressing through the stages.
You mentioned earlier on that you briefly explored Argo and sort of ran into some challenges with
So the question was about why we didn't use Argo. Mostly because our architecture is meant that every cluster is fully self-sufficient. So we have our centralized control plane for copy, but that is mostly just there for mitigating failures and for upgrades. But every other function in cluster is completely self-sufficient. So for example, the monitoring stack that runs in a cluster is completely self-contained in the cluster. We have a Tanos in front of the Prometheus in that cluster for us to centrally aggregate things. But if another cluster breaks or a control plane breaks or whatever happens, that cluster, that application will continue to run as it's expected. So we didn't want to basically remove that architecture. So we can even roll out upgrades or fixes to that specific cluster if our management plane is broken or doesn't exist anymore. You can still roll out a security bug fix. You can change configuration on that cluster. They're completely self-dependent. Yeah. Yeah. Yeah, but we would need to have a few hundred Argo instances. We are currently at about 170 clusters. Yeah, but they're easier to manage and install because they're just custom resource definitions that get one time applied and then self-reconcile. The question was whether we couple Argo and Flux. So we're still just using Flux. There is no Argo in our new approach. It's still completely self-contained with Flux v2 CRDs. We will probably not switch over because Flux is getting the necessary features that we need from it.
Yes, thanks. So at the moment, the one that changes stuff in the Git repo, how is that done? Is it kind of humans all, and how is the kind of, or is there any UI in front or?
It's mostly our platform team, so the people that are responsible for the platform. We have tooling that automates a lot of the things, but it's currently mostly run on our PCs. That's not something we want for the long term. A team member of mine is going to hate me, but it's mostly held together by Python glue code. There are Python scripts that just iterate over every cluster. We have different resources that just pin specific clusters. We have a resource that handles which target version should be in every cluster. There's just tooling that manually reconciles it. It's not automated yet. It's the plan to do so, but it's not done yet.
Okay, and the kind of, is there any access control between, so if you have a mono repo, you have kind of 170 clusters in the same repo. Is there any use case for having just someone access a couple of them?
Yes, we have owner files and approvals. So it's GitLab. We have a way too complicated owner file. We have some CI hooks that do for things like notification of our internal tenants. We have also that will fail if you do some changes, and then only a very limited amount of people will be able to merge it. But in general, we have owner files for different things, or one owner file that allows different people to merge and approve different things using merge requests. And I think 2 people are actually allowed to circumvent that.
Okay, cool. And maybe the last question, if there's no other, did you consider Q for the templating stuff?
What again?
Q, C-U-E.
We never looked at it.
Okay.
Well, short question is, did I understand correctly that you kind of abusing Helm as just templating engine to generate configs?
Mostly, yes. So we use Helm to basically stamp out configuration for Helm charts, basically.
And then you just proceed with customize, right?
It's just basically creating a Helm release CRD and the necessary Helm chart repo for Flux in the cluster, and then Flux will reconcile all of that on its own.
Okay, and now the major question. What would you do if you would start fresh all over?
Honestly, we would try to streamline our environments more and accept less weird environments. Right now we are there. We have things in there that are in production, so we can't get rid of it easily. Ideally, we would never have started doing things there.
But would you still go for this architecture with Flux and the Python scripts and Helm, the whole quite complex environment, or would you go for a more simple architecture?
We are working towards a bit simpler architecture by writing more of our own operators and our own CRDs to manage things. It's not fully done yet. It's done for some parts, mostly around actually creating those things around copy. That's where we currently put the emphasis of writing that operator code, but we also have plans to extend that into the components management and basically automate Git commits through that. We still want to have the intermediate step of Git, so we can basically revert individual clusters, block commits to that Git repository, and make sure that way that we don't break production environments. Because if we break production environments, the impact is a bit higher than usual. It's not just the web application that's not there. It might be emergency calling for 20% of Germany that's just gone.
Thank you.
So I guess no more questions. Then thank you all for your time.
Voor mijn intieme verzorging gebruik ik Lactacid.
De uitwendige intieme zone heeft van nature een lage pH. Een hogere pH, zoals van zeep, kan deze balans verstoren. Lactacid is specifiek afgestemd op jouw intieme zone. Lactacid beschermt jouw natuurlijke balans.
Hello. Hi, everyone. Sorry, that was a test hello, but this is the okay, not test, final hello. Hi, welcome back. Thank you for coming, for those of you who've actually come back. I hope you had a lovely, long, leisurely lunch break. We're back for the second half of the sessions on day 1 today, and we have Giovanni Galloro, who's going to be talking about scaffold and continuous deploy. Sorry? It's not? Hey, it's not working. Are you really? Yeah, now. Hello? Yes. Ooh, did you hear the reverb on that? Oh my God, yes. Okay. So hello and welcome. Thank you for coming back. I hope you all had a lovely, long, leisurely lunch break. We did explore a cute little cafe close by, and I highly recommend it the next time. It's called Granny's. Wonderful. Yeah, lovely place. We're back for the second half of day 1 sessions, and we'll start with Giovanni Galloro, who will be talking about scaffold and continuous deployments. Yay!
Thank you. Thanks a lot. Thank you. So, scaffold, what is scaffold? Okay, yeah, slides are there. So I will talk about scaffold, and we'll start about the problem that it tries to solve. The initial problem that scaffold has been created to solve is that if you want to develop an application to be deployed on Kubernetes, and you want in some way to test, to experiment how this application will behave when it is in production, and you want to kind of test it in an environment that is similar to production, no? That has some parity with the production, you need to do a lot of tasks, a lot of things. You need to build your image properly, you need to tag your image, you need to push that image on a container registry if this is intended to be deployed to a remote cluster. You need to render manifest, deploy manifest. You need also to forward ports. If, for example, this application, the cluster you are deploying to, is not exposing the application externally. And you have to do this again and again for every change that you do. And you don't only have to do that, but you also have to do all these tasks using different tools. You need to use Docker for build and push. You need to use an editor to manage your manifests. You need to use kubectl to deploy actually your application. And this produces kind of context switching in your work, no? So, and in that case, the so-called development loop, inner development loop, the time that passes from when you change something in your code and when you have the result of your change in a target cluster, in a target environment, becomes longer and longer. And this is the problem that the people that created this tool wanted to solve. They wanted to have something that as soon as you change your code, this code was reloading immediately and deployed on a target Kubernetes cluster. This is why Scaffold was created. What is Scaffold? Scaffold is a cloud-native developer productivity tool. It's an open source tool. It's actually an executable. It's actually a command line tool. It's part of, this is the repo where you can find it. Is part of Google Container Tools. And it basically condenses all the tasks that I mentioned in a single command, scaffold dev, using a single tool. It uses a declarative and portable configuration. We will look at that. This is important. Basically, scaffold is composed by an executable and a configuration file. And it has a pluggable architecture. It can use different tools for building images. It can use Docker, it can use Gib, it can use build packs, it can use Canico, and it can do that also in different environments. It can build images locally where Scaffold runs. It can build images using a remote Kubernetes cluster, so running the build in a remote Kubernetes cluster. It can drive cloud build. And it can use different tools also for the deployment. It can use the simple kubectl, it can use Helm, it can use Customize for the deployment. These are the main use cases of Scaffold. As I said, Scaffold has been created to optimize this development loop. No? So having a developer experiencing immediately the result of his work on a target development clusters. But this use case has been extended also to continuous integration, so build artifacts that can be used in a continuous delivery pipeline, and render manifests that can be used in a GitOps workflow, and also continuous delivery in terms of using Scaffold to actually deploy an application on a target environment or on multiple target environments. This is an example of a Scaffold configuration file. So everything Scaffold does is based on a configuration file. As I said, two components, executable and configuration file. To start working with Scaffold, you need a configuration file. If you don't have a file, Scaffold can create one for you. This basically has the structure of a typical structure of a YAML, a resource that the people that work with Kubernetes resource model are used to. It has a kind, an API version, and it has, let's say, three main sections. One is build, one is test, one is manifests. Okay, let's say that for simplicity can have also different sections, but these are the three main sections that Scaffold has. And with these main three sections, it has this pluggable architecture I was mentioning. No, it supports different tools for build, Gib, build packs, Docker. It supports also custom tests during the build for your application. It supports different tools for the deploy. And this makes easier for example, developers to choose their own tools, operators or the people involved in application delivery, in application release, to choose their own tools. And if one of the party want to change, it doesn't affect the other party, because there is a kind of abstraction layer provided by these blocks inside the Scaffold configuration file. So once you have that configuration file, what you can do? You can use a single command, as I was mentioning, Scaffold dev, that does all the tasks I was mentioning before. Okay, build, push, deploying, and forwarding the ports, and having you looking at how your application is behaving, and continuously watching your directory, your code for changes, and do the same every time that your code changes. I wanted to show, if demo gods are with me, an example of this. To do that, I hope it is visible. To do that, I will use a development environment that is called Cloud Workstation. These are development workstations hosted on Google Cloud, running in a VPC and in a GCP project of the organization where the developer works. So are workstations that can be used to keep the code inside the organization VPC, and having not the code running elsewhere, everywhere, and keeping this secured and updated in the cloud. But I use Cloud Workstation for my convenience, but you can run Scaffold everywhere, on Linux, on Mac, on Windows. So let's start with a repository, an example repository. Let's clone a repository. I have a repository here. This is on my personal GitHub account. It has some example application to use with Scaffold. I can clone this repository, and I will clone into my home directory and have, in this case, this is OSS code. This is the open source VS Code that we expose in Cloud Workstation, but as I said, we can run this everywhere. So I have different folders. For example, I have this simple Go folder. Is a very simple project where I have this source code that basically prints this text on a web page. Scaffold explained up running in target, where target is the value of a variable that it picks. It has a Docker file, a basic multi-stage Docker file. It has a Kubernetes folder containing one Kubernetes YAML file that defines two resources, one service and one deployment. Simple two resources. One thing is that the deployment sets that variable, the target variable, to the value dev. Okay, I don't have a Scaffold YAML file. As I said, the Scaffold can create that for me. If I run Scaffold init, if I run the command Scaffold init inside the folder, I hope it is visible. Scaffold proposes me a configuration. No, as you can see, it proposes me a very basic Scaffold YAML file where it proposed me to use Docker to build my image. In that case, because since it detected a Docker file, it proposed me to use Docker. Okay, I can save, and I have now the Scaffold YAML file inside my repository, inside my folder. It can propose different things. For example, I have this other folder, Go Full, where I don't have a Docker file, but I have a Go module file. So it's a more proper Go folder. And in that case, let's see that what the Scaffold will propose me. If I run Scaffold init again, in that case, I have a Scaffold proposing me to use build packs because one, it didn't detect a Docker file, and two, it detects that this is a Go project, so it knows that can use a build pack to build an image, merge the Go code with the proper builder to use build pack to create a container image. Don't save that. I have another one. This is a Java project, still without a Docker file, but in the case with the POM.XML, this is a Maven project. So if I go and try this one, let's see what it proposes me. Okay, now it asks me to choose between build packs and Jib because it detects that the Maven project support the Jib Maven plugin to another way to build images without using a Docker file. So the point is that depending on what Scaffold init finds inside the folder, it proposes different things. By the way, it can also be run with an option to create Kubernetes manifests if they are not present. Let's go back to my very simple folder. And now let's use this Scaffold YAML file. Let me pick this one. Let me be sure that is the right one. By the way, the Scaffold init actually create a basic Scaffold YAML file, but you can start from this and customize this for different needs. For example, I should be able to add a port forward configuration, so I have my application exposed with a port forwarded to my localhost, so I can access that, and I can add this at the end of my file. Okay. Or I can, for example, add something related to tests if I'm able to find. Okay, I can add this test section, where I basically say, let's run my container image, let's print this thing. This is a custom test, but this is the point is that you can run any meaningful script or test that is meaningful for your application. Okay, now I should be good to go for the scaffold dev. By the way, I'm using Minikube for this. If I look at my context, I have in my kubectl, in my kubeconfig context, I have 3 clusters, but my default is on Minikube. I decided to use a local Kubernetes environment because I want to have, as a developer, a Kubernetes cluster running where my scaffold runs. This is not mandatory. I can use any Kubernetes cluster that I want. So let's try this scaffold dev flow. Okay, it starts to build the image, and it run also the test. Where is this? Is a common test. This is a custom test command. Here it is, and then it forwards the port forward, so I can access the application. Okay, I can see the output of my application running in dev because it reads the variable. I can work on my application. I can code my application. I can, for example, change my code. As soon as I change my code, scaffold start to build my application again. Okay, I have an error on the port forward. This happens. But okay, I have the port forwards working as well, and this has been updated. Okay, so this is the scaffold dev flow, the flow related to the developer, to the developer workflow. Scaffold can do also other things, okay? Beyond doing that, the actions that Scaffold does can be done also, can be picked independently and can be used inside a continuous delivery pipeline. Scaffold can be, using the sections that you saw in the Scaffold YAML file, the Scaffold configuration file, you can drive other tasks of a continuous delivery pipeline, and you can pick these tasks independently. You can pick the ones that are meaningful for continuous integration or that are meaningful for deployment of your application on target environments. For continuous integration, you can use a command called scaffold build that basically builds your image, tags, pushes to a registry if needed, and puts the coordinates, the reference of the artifact it produces to a JSON file that you can reuse in your pipeline. Now let's see also that if I do a Docker a scaffold build with I need to put a file output at the end, okay, because I need to define the output JSON file where I put the coordinates of my image. Now he didn't build the image, he just tagged the image because the image is already present in the Docker engine of Minikube that it is using. But it created this artifact JSON where there is the tag of the application. And another thing that it can do, it can also manage the deployment part. Now, with another command, scaffold deploy. Scaffold deploy basically takes the tag that is inside this JSON file and render the Kubernetes manifest. So put the specific tag, the specific version inside the Kubernetes manifest, and then deploy the manifest on your target environment. So since I did the build, I should be able to deploy that in, I don't have to put the cluster at the moment. I just put artifacts JSON as the input of my deployment, and I should deploy on my default context that is still Minikube at the moment, okay? So it is deploying. If I look at what I have, here I have my scaffold example application with one pod deployed on my target Minikube cluster. It can also split this deployment part into. There is another command, is scaffold render. Scaffold render basically does only the render part. So it just hydrates your Kubernetes manifest with the specific tag of your image. So you can use this manifest, for example, for a GitOps workflow. So you can put this manifest in a Git repository, and you can use Argo CD or Flux to actually deploy your application based on this manifest. Scaffold support also scaffold apply, the second part, the counterpart of scaffold render, where it just take the manifest and apply the manifest on the target environment. I should be able to show that as well. Probably I have to. No, this is too long. I should delete. I do a scaffold delete. If I do a scaffold delete, it removes all the resources it creates on the target environment, and I can do a render. Sorry, scaffold, is it? Okay, I do a scaffold render with in input the JSON file that I created when I did the build, and as an output argument, the render YAML, the target manifest, the hydrated manifest that I'm going to produce. So I produced this render YAML that is basically the same manifest, but it has been tagged with the specific tag of the image I built before. Then I can apply my image with a scaffold apply, giving as a render YAML as an argument, okay? And I should have the image applying on the target environment. Okay, another thing that scaffold can do is manage the deployment across different environments. Because we said it can be used not only to optimize the development work, the development loop, but also to progress the deployment of an application on across your continuous delivery pipeline, so across different environments. To do that, I show you an example. For example, we have this scaffold YAML file. I moved it to another folder, is this Go multi folder. I have this scaffold YAML file. This is a bit more complex. It has a manifests section. Manifest is where the deployment is managed, the rendering and the deployment is managed, that uses customize, and we will go to customize in a minute, and uses the manifests that are inside Kubernetes/dev. And then it has another section called profiles, okay, where it has two different profiles, one named QA and one named prod. Each of them uses customize, and each of them referring to a specific folder for Kubernetes manifest. Do you all know what customize is? Okay, I think you all know, but just a quick recap. So customize helps you to create multiple Kubernetes resources, for example, different version of the same application, different deployment of the same application in different environment, without creating different manifests, but starting from a common configuration, starting from a single manifest, and adding manifest with just the changes that has to be applied to this common configuration. Here we can see an example. Here I have this base folder where I have this customization YAML file. Customize use this file to define how the resources defined inside a folder are created. And in that case, this customization file states that if I target my base folder, my resources will be created using the deployment YAML file. The deployment YAML file is basically the same file that we saw in the previous example, defining a service and defining a deployment. In that case, it doesn't have the target variable set. And if we go to look at the different folders, for example, the QA folder, in that case, the customization YAML file states that the resources for this folder are created using the base, what's in the manifests that are inside the base folder, applying on top of them this target YAML file. And the target YAML file basically adds this variable, the target variable with the value QA. If I look at the prod folder, for example, I have a similar configuration, merge the base, what's inside the base with this target YAML file, and the target YAML file adds a target variable with the prod, but also change the number of replicas of my deployment, because, for example, in production, I want to have a different capacity. Back to my scaffold YAML file, as I said, it uses these profiles. What are profiles? With profiles, scaffold can apply a different configuration to a different context or a different environment based on, for example, a command line parameter or an environment variable or a command that is inside the scaffold YAML. Let's see an example of this. First thing, in that case, I will use some GK clusters, remote cluster. I will not use Minikube because I'm deploying across different environments. So I'm stopping Minikube to avoid use a local context. Let's unset some variables and let's see my context. Okay, I have these two clusters, prod and QA. These are actually two GK clusters I created. I have also an artifact registry repository because it's called demos, because now I have to push my image somewhere because my image will run on remote clusters and it has to pull my image from somewhere. So what I do, the first thing I do, I have to build my image again, okay? In that case, I should okay, I'm losing this one. Let's see if I'm able to. No, I'm not. So, scaffold build. Type everything, and this should be target repo, and I should add my repo here. Okay. Because in that case, the build also is it. Okay. First thing, go to Go multi. Let's try that again. It's not target repo. Let's go in for the help. It should be. Default repo, not target repo. Okay, let's try if it works. Now it's building. It should be able to push that image in my artifact registry repo. Okay, I should see my image here. Okay, these have been populated. And then I should be able to deploy that. In that case, I do a scaffold deploy, but I put the QA as an argument to use the QA profile, and kube context with the argument to deploy to the QA cluster, okay? I can do the same for prod. I'm finished. Is the last one. I can do the same for prod. Okay. Okay, I should be able to check that these have been deployed. Okay, so this has been deployed on QA cluster. Let's see on the prod cluster. In that case, these are remote GK cluster. It takes time. As you can see in the prod cluster, I'm deploying 3 pods. In the QA cluster, I'm deploying a single pod. Now I have my external IP address attached to the QA cluster. As you can see, is deployed in QA. And this should be the same for the prod cluster. Okay, with an IP attached to that. Just one last thing is that scaffold is used also inside GCP tools, GCP products. For example, inside the Cloud Code. Cloud Code is a set of IDE extension that let you to interact with GCP APIs and use this continuous development loop directly from the IDE. Is provided as an extension for VS Code, for IntelliJ, and through web browsers like with Cloud Shell and with Cloud Workstations. And Scaffold is used also in Cloud Deploy, that is the managed service on GCP, to actually manage the progression and the promotion across different environments and the configuration of an application in different environments. And how how Cloud Deploy does that, it actually, behind the scene, uses Scaffold render to hydrate the manifest for different environments and Scaffold profiles, and Scaffold apply to actually deploy the images. Finished. I don't know if there is time for questions or...
Hear me better? Yes. Okay. Yeah, I'm afraid that's all we have time for, but we can take a quick question or two. Yeah?
When you did the Java example, it recognized the POM XML and it showed build packs or jib. Do you already have to have either the jib plugin in that POM XML or jib on your system for it to do that, or will it recommend tools that you might not have?
I think the last version check inside the POM XML if the jib plugin is defined, because I think the previous section had a more sophisticated algorithm, but this took time and CPU. So now in the POM XML, there is the jib plugin defined. So yeah, it checked for that.
As a quick follow-on, sorry. Can it also support Co for Go? Co is the Google image building.
I'm not sure I saw any...
Well, let me expand that. Can it be expanded to support other tools that don't exist today, or is that something that would have to be added to the project?
You can use custom builders. I don't remember I saw code defined inside the build sections, but you can basically use custom builders running, for example, on a target environment, yes.
Okay, can you do one more while I got the mic? As far as the life cycle of things it does, can other tools like Cosine or Sneak or something else be added to the things it does as it's doing the builds?
Yeah, basically it manages, it provides a configuration valid for build, test, deploy. You can mix these things together, no? For example, you can, when you do the build, you can mix assigning, use assigning for that build. When you do the deploy, obviously, if you have an admission controller running on the target environment, the admission controller will say yes or no, and your deploy can fail or cannot fail. Some of the things I didn't elaborate are that, for example, you can add a verification step inside the scaffold YAML file. So put something that has to be successful for your deployment to succeed, or these are things that have been added lately. Yes. Thank you.
All right, that's it. That's a wrap then. Okay.
Thank you. Thanks a lot.
And next up, we have Mary Fasenko. This in 10 minutes. So, Mary, I think we have less than 10 minutes to get you all ready. But so I'll request everyone to stay put. And yeah, we'll begin shortly. it's fine now. All right, now we have Mary Fosenko from Chronosphere.io. Did I get that right? Yes. Okay, wonderful. Yeah, I should have checked that earlier. Mary will be talking about the evolution of deployment tooling there. I'm quite curious about Chronosphere.io, so I'm really looking forward to this talk and hope you are too. And yeah, stay put. And Mary, take it away.
Yeah, thank you. So now we just need for this thing to work. Brilliant. So hi everyone, my name is Mary. I'm a software engineer at Chronosphere, and today I want to tell you about evolution of deployment tooling at Chronosphere. And a little bit about me and why am I actually talking about deployment tooling. So born and raised in Ukraine, studied there, started my career there. And back in 2017, I moved to Denmark to work for Uber. And that was the first time that I worked on the infrastructure team and kind of got excited about the area and found it quite fascinating to work with. And then in 2020, I moved to Lithuania to work for Chronosphere, where I also ended up on an infrastructure team. And basically on both infrastructure teams, I eventually ended up working on deployment tooling, learned a lot about it, and that's how I end up talking about it today. So basically, long story short, when our company was just 1.5 years old, we decided that we want to build our own deployment system. And now it's been 2 years since that moment, and I want to look back at the time and tell you a story about why we did it, how we did it, and what we learned in the process of building it. But before we answer the question why, let's just talk a little bit more about what Chronosphere is, because most likely you don't know about it. So it's a hosted observability platform that is built to handle the scale and complexity of cloud-native metrics. It's powered by M3DB, and M3DB is a time series database that was built and open-sourced from Uber. It was battle-tested there, and basically it's a really solid foundation that we have, and we decided to build our own observability solution on top of that. So when we're speaking about deploying Chronosphere, what does it actually mean, right? So we run all of our software in the cloud, and our clusters are managed by Kubernetes, and we run in a multi-tenant setup where for each paying customer of Chronosphere, we have a completely separate Chronosphere stack. And we model them in the Kubernetes world as separate namespaces. And then in each of these tenant namespaces, we deploy a bunch of stateful and stateless services that basically build up a Chronosphere product. And then for our stateful components, such as M3DB, M3 Aggregator, which are part of our time series database solution, for them we have custom Kubernetes operators that help us automate a lot of different operations for managing the database cluster. And basically, when we deploy software, usually people don't deploy just one service at a time. Each engineering team owns a subset of services. We call them a group of services. And then each team decides their release cadence, their release validations, and basically take off with their release process that they have. And one thing that we're noting, since Chronosphere is an observability and monitoring platform, we use our own product for monitoring our stuff. So basically all the dashboard, all the alerting, everything that we have, that is in our own product. And one of the things that was important for us, the deployment tooling can kind of integrate with that. So if we go back in time 2 years and look at how we did deploys back then, when we were just really young and excited to deploy stuff to prod as fast as possible. So we built a simple CLI command, and basically the engineer would call it and say, I want to deploy this subset of services to one tenant. What the CLI would do, it would connect to our production environment, compare desired state with existing state, generate you a diff of changes, show it to you in the output of the command, and then you can get the chance to kind of review it. If everything looks okay, you say, okay, let's proceed with the deployment. That same CLI connects to the cluster and just blasts out the changes. But can you actually consider that deployment is done after you completed this command? Of course not, right? So this is when you as an engineer have to do all the dirty work. First of all, you want to know, did my changes apply, right? So you will probably use kubectl and go and find the services that you're deploying, check that old pods are being killed, new pods are coming up healthy. Hopefully you deployed a really healthy change, everything is great, but still quite a bit of manual things you need to do to verify that it actually got there. Then the next thing that you would probably want to do is go to your favorite dashboards and Chronosphere product and check, is everything looking okay? Is CPU suddenly spiking through the roof or error rate is increasing? Hopefully everything is fine there as well. So then you look at the alerts, you look maybe at PagerDuty and check that there's no incidents that started after that. You started the deployment, you wait for some time, 5 to 10 minutes, let's say. Eventually, you decide, yes, we deployed this tenant, everything is healthy, everything is fine. And then the worst part of it all is now you have to repeat all of this from the beginning for each tenant that you have. So if we look what was good about it, at least some minimal automation. And at least you can deploy changes to a group of services. You don't have to change each individual resource. Like, at least moving a little bit in the right direction. And one other thing that was nice, that users were able to review the diff as part of this flow. But then let's talk about all the bad and the ugly. The main problem of it all is that users own monitoring of this process, because basically you as an engineer, you have to decide is deployment successful or not? When is it actually completed? When do we decide to roll back? And in order to do that, you also have to switch between multiple tools, which, like, let's be frank, nobody likes that. Nobody likes opening 5 windows and stressing out whether things are going well and switching between all of them. And that was made even worse, that you have to repeat it manually for each tenant. So in the beginning, when you're a young, excited startup with 3 clients, you're fine. But as your business becomes more successful, that is becoming more and more painful. And together with that, rollbacks are becoming more painful as well. Because, again, it's up to you to decide whether we need to roll back, and then you need to remember who did you roll out it to, how do we quickly undo all the changes, and it's really stressful. Monitoring rollbacks is stressful. It was not really a sustainable way to continue. And then another thing that was a bit annoying, that basically we had to give full production access from all engineering machines in order for that CLI to work, and we didn't really want to have that. So as we were growing as a company, we knew that we can't continue like that, and we need to make some improvements in this process. So this is when we had to answer the question to build or not to build. And before we answered that, we decided to first gather some requirements to what do we actually want from a deployment experience that we want to have. So it was important for us that it's easy to model our Kubernetes setup with namespaces and services and all of that. We wanted to be able to have additional custom health checks during the deployment. One really important bit for M3 components, since we had those operators, we wanted to have integration with them because we wanted to reuse all of that functionality that we had for managing the database cluster. And then all the basic stuff, you want to be able to track the progress of your deployment. You want to get a clear signal when something goes wrong. Then, since we use Chronosphere for monitoring, obviously we wanted to be able to integrate with our product, have some integration with logs for debugging purposes and checking that things are going well. And if we would go with a hosted solution, we wanted to make sure that the vendor access to our infrastructure is as limited as possible because we didn't feel comfortable giving them full access. And back when we were trying to answer this question, that was the end of 2020. So we reviewed a bunch of open source solutions, a bunch of hosted solutions, and we didn't really find anything that would fit our use case really well. And at that point, since we had a pretty clear list of requirements, we decided, let's see if we can actually build this, right? So now let's talk about how we actually build it. So first then, that is worth mentioning, that deployment process from the way we were seeing it in Chronosphere was a pretty well-defined sequence of steps, which makes it pretty easy to express as a workflow. And previously, we used Temporal for automating other workflows, for testing and other purposes, so we decided that maybe we can just use the same approach here when building our deployment system. So what is Temporal? It's an open source platform for reliable workflow execution. Basically, you write a workflow in your language of choice with the help of Temporal SDK. Then you spin up workers being able to run that code. They connect to Temporal cluster. And then when you schedule a workflow, Temporal will take care of making sure that your workflow is executed in a proper manner. And in case some intermediary failure happens and your workflow kind of experiences a failure in the middle, then Temporal will reschedule it on a different worker exactly from the spot where it failed. So this way, you're kind of a little bit more resilient to failures. So this is how we structured our deployment workflows at a high level. So the first workflow that we had was deploy service. Does exactly what it says in the name. It deploys one service, applies the changes, waits for them to complete, or fails otherwise. Then the next level was deploy tenant workflows. That is responsible for deploying changes to one single tenant. It would initiate multiple deploy service workflows. and wait for them to complete, figure out in which order they should be deployed, and then perform additional monitoring. For example, it would check whether any of the critical alerts went off since you started a deployment and wait for maybe 5 minutes after deployment completed. And then the high-level orchestration workflow is responsible for deploying multiple tenants within a cluster, deciding how fast do you go, how many tenants at a time do you deploy, if something goes wrong, how do you handle failures, how do you handle rollbacks. So let's look a little bit more how user flow changed from this, right? Engineers would still use the same CLI, just a different command, but now you would be able to say that let's deploy these services to a bunch of tenants, or maybe even all tenants in the cluster if you want to. But instead of connecting directly to our production clusters, this CLI would now talk to deployer service. As you can see, we didn't think twice about the name. We just call it the way we thought. It's deploying, let's call it deployer. And basically, a deployer would kick off the workflow and connect to all the systems that you need to connect to perform the deploy, monitor it, and kind of take you through all the necessary steps, while you can still use CLI to track the status. You can use it to initiate rollbacks, cancel, or check history of deploys. And then if something goes wrong, you would be notified through your Slack integration. So speaking of Slack integration, this is kind of how the message in Slack looked in the early days. I know it's a little bit scary and hard to comprehend, but basically what it normally says, it's like, in this tenant, you experience this kind of failure with additional link to maybe alert that triggered the failure. And then it would offer you a choice of options of what you can do, right? You can either stop and abort the rollout and kind of investigate. If it's your testing environment, you might want to check what's going on, or you can roll back. And this way, we kind of made rollbacks more accessible and easier to perform. If you're doing a multi-tenant deploy, you would also have options to roll back just one tenant, or roll back everything and just go back to the safe state of the world. So we rolled out the first version of deployer within like 1 or 2 months, gave it to all engineering teams, they started using it, and after we gathered some feedback. So what did people like about it? They liked that you were able to deploy changes to multiple tenants with one operation. It was a much nicer experience. But then it was nice to have automatic monitoring for checking that no alerts are firing or detecting whether the service actually is failing to start up. Honestly, in the beginning, engineers were a little bit skeptical at first, as all of us are, and they would still open all the dashboards and check the alerts and do it manually. But over time, we gained their trust that our tool is doing the right thing, and most of the time, I think these days, people rely on the monitoring that we have inside the system. As I already mentioned, it's easier to initiate rollbacks. And another thing that we got out of the box now, since we were storing all of these workflows and the rollback history, you had access to the history of changes. So now if you're looking at different metrics and see that something went a little bit crazy Thursday last month, you can actually go back and compare it with what operations were performed at a time. Maybe you can connect the dots and play detective a little bit better with this tooling in place. But things were not perfect still, right? Another thing that we got out of feedback from people is that different teams actually had different requirements to how they wanted to perform deployments. Or as we were growing and getting more services and more tenants, duration of deploys started taking longer because one workload was responsible for it all now. And also, as number of tenants was growing, it was harder and harder for a person to actually track the progress of the deployment, given that we still had it in the CLI. So speaking of this last one, here you can see kind of a screenshot of how tracking the status of one deployment for 2 tenants and like 9 services each, I think, looked like. So you can see it's a little bit already hard to comprehend and figure out what's going on. It's just a wall of text staring at you. And now let's imagine this for 10 tenants, for 20 tenants. This is not really something that we wanted to look at. And basically, this is when we decided that it's time for infrastructure engineers to become brave and learn a little bit of React and try building UIs. So this is what we ended up with. I know it's not pretty, but we tried our best. We used a lot of colors at least. And basically, the first version of the UI was just read-only, focused on 2 things. Finding your deploy, reviewing deployment history. Maybe you want to find something you deployed 2 days ago, or maybe deployments for a particular service. And then after you open a deployment, you would be taken to this other page that shows you the status of one deployment. And we tried to use more interactive components that we could afford in the CLI and basically use all the good tools that UI can help you. And yeah, after we rolled this out, I think engineers, even who were a little bit skeptical about switching over to the UIs, they also eventually believed us that it's much nicer experience if you do it within your browser and have access to just better visualizations. So we built this first UI, just read-only, got really excited about extending it. The next thing we decided to add to the UI is rendering the diff. So before I mentioned that we were showing the diff in the CLI, the way it worked, you would generate it in a temporary file on engineering machine, and show it for like a few seconds, and then you never see the diff again. Turned out that people actually want to be able to look at their deploy from a few days ago and see what exactly has changed. So it was a no-brainer that this should be added to the UI as a functionality. So we got excited, we moved it to the backend, added support on the UI, rolled it out, and thought everybody would be happy. But in the meantime, we actually heard developer experience because we didn't think it through a little bit. Because what happened? A person starts to deploy in the CLI. Right. Then the UI gets auto-opened with the diff. So you look at the diff, but then you need to be able to proceed and say like, hey, it's okay, I'm happy with this diff, let's proceed further. And for that, you will see like a Slack notification somewhere here. If you didn't disable Slack notifications because they're noisy, you need to find it in Slack, you need to confirm it, then you go to the UI again, and you're trying to track the progress. And then if something breaks again, then again another Slack notification. So you're switching between 3 different views, and just hating the day where you decided that you need to deploy something. So we heard it from basically the first days of rolling it out that this is not sustainable. So we quickly started prioritizing the work for moving all of this confirmation from Slack to the UI. After we did that, the process became much better, more streamlined. You start operation in the CLI, then you go to the UI, and everything happens there after all. Slack notifications are still working, but they're still kind of just a bit of a support mode. And hopefully in the future, we will also move everything to the UI just to make it easier, but for now, this is kind of where we left it in the UI land. In scope of working on this project, we also did a lot of other interesting things. I don't have all the time in the world today to tell you all about it, so just wanted to quickly mention. So we provided more control over the speed and safety of the rollout, prevented concurrent operations from happening. We added auto rollbacks on failure, generating release notes, implemented more interesting operations such as persistent disk expansion and shrinking specifically for our storage components. And we were able to fairly easily add support for deploy freezes, which is kind of saving us during vacation and holiday times. So now let's talk about the lessons that we've learned as we were building all of this functionality. First one is that user needs are important. And I think if you're an infrastructure team and you're lucky enough to build tools for other engineers, you're in a really lucky situation because you basically speak the same language with your stakeholders, and you can definitely use this to your advantage. And basically just talk to them, gather feedback from them, go through the operations that they're going through and experience the pain together with them. And then I'm sure together you can come up with a really good solution to the problems that they're facing. The second lesson that we learned is kind of connected to the first one. It's less is more. Because as you listen to your users and you gather the feedback, you might get into a trap of implementing absolutely every suggestion that they have. But at the same time, you might impair the developer experience quite a bit. One case in point is basically the screenshot in the background. This is a help for our command for starting a deployment. As you can see, it barely fits the screen, and one needs, like, I don't know, a magnifying glass to read through it, right? And for anyone who's been at the company for a while even, it's kind of hard to comprehend what's going on and assess all the options that you can use when starting a deploy. Imagine if you just started a week ago and you're staring at this again. You will never want to do any deploys ever. Next lesson that we learned was about visibility. Well, it's not that hard to build a solid solution for a problem that works fine most of the time. It's the last 5% that matter when something goes wrong. And we've noticed this especially when deployments go wrong. It's really easy for us to say like, hey, it failed, go fix it, right? But actually, it would be a much better experience for people if they would have a clear answer, why did it fail? Or you can say, oh, the service is not starting up, but that is not clear enough. And this is basically the area where we can still do a lot of new improvements and kind of take it to the better level and provide kind of faster time to mitigate issues for people by just providing better visibility. Next lesson that we've learned was about reusability. basically, as we were building out these workflows for deployment, we built a lot of small building blocks for interacting with different services, with Kubernetes, with our operators, with different storage solutions. And later, when we were automating other operations, such as restarting services, different cluster operations, different end-to-end tests, we could reuse all of that. And I can confidently say that we will continue doing that moving forward as we're automating more and more operations with the help of Temporal. And the last lesson that we've learned was about dependencies. So when you build infrastructure level tooling, I think it's really important to remember that at some point, a lot of processes at the company might depend on your tooling. And the lesson about dependencies we actually learned during a global Slack outage, which was kind of silly. But basically, Slack had an outage, and if our deployment workflow wasn't able to send some kind of information level message to Slack, the deployment workflow would just fail and not allow you to continue at all. Which means if we're having an outage and we need to deploy a hotfix, we can't do that because of the silly dependency. So fixing it was like half an hour kind of thing, but it pushed us to think more about how should we treat dependencies. And every time that we ended at dependencies moving forward, we need to make sure that do we actually need it? And how do we deal with it when the thing you depend on is down? So looking back at the last 2 years, I can confidently say that building our own deployment solution for us was the right thing to do. But I don't think it's the right thing to do for everyone. In our case, we really needed this level of control and configurability, especially when we need to deal with our stateful components. And also our deployment flow is not that complicated, and we don't expect it to get much more complicated. But I think for a lot of people, it's too much of a time investment, it's too much of resources that you need. And we also face quite a lot of challenges by trying to get it right, trying to get the better developer experience. And we will continue working on this and improving it all and try to strike the right balance between providing reliable functionality and good developer experience. So thank you so much for your attention. I hope you found this somehow interesting, and I'm happy to answer any questions that you might have.
We have about 7 minutes, so we can take 2-3 questions. Okay.
I was just curious, what came before Droid CLI?
I wasn't there to witness it, honestly. And I think from the beginning, we tried to do everything with the CLI commands from the start. Maybe there were some gnarly shell scripts, most likely. That's what I suspect.
Was this the first time your platform team built a custom CLI tool to do something?
I think from the beginning of the company, we would always try to automate it as code and preferably testable code. I think anytime that we needed to do anything, like we also built a lot of other things, like we have support for testing environments on demand for engineering. We automated a lot of that. So I think we had a lot of efforts in parallel. And I joined kind of when the company was, I guess, 1 year old, a little bit more. And I had a really strong impression that from the start, if we saw the need to automate, we would rather pay that price in the beginning. Even if it's not going to be perfect, it's never going to be perfect, right? We're still far away from being perfect. But at least trying to push the needle forward, I think that kind of was helpful.
Thank you.
I was interested in rollback. I mean, are all the tenants the same, or would you be in a situation where some of them deployed okay and others failed, and would you roll everybody back, or how did you think about rollback?
Yeah, so we support both modes, and quite often, even when you deploy, you might be going from different versions, right? Because someone will be lagging behind for some reason and things like that. So I think when it comes down to rollback, we try to provide more flexibility into if you have seen only problems in one tenant and you see everybody else is fine, and usually one of the tenants might be a snowflake, they have some special configurations that only triggered the problem. You can trigger only rollback for one, but I think in a lot of cases, for safety's sake, if we're not sure exactly why it's happening, and normally you're not, right? A few minutes in, you're just panicking, shit, I can't release changes today, now I have to go back. I think most of the time we try prioritizing rolling everything back, but it depends again on the service. If it's stateless stuff, we would rather roll back everything. it's fast. If it's stateful stuff that can take hours, this is when we might make exceptions a little bit, but I think also then the teams are handling deploys a little bit separately and trying to figure out what is the best way for them to proceed.
Hey, thanks for the presentation. So we saw earlier as well T-Mobile trying to build platforms, and all platform teams that usually go more the GitOps way or operator pattern. So can you maybe elaborate on this temporal tool and maybe alternatives which are kind of like more powerful to actually achieve this kind of deployments at scale, either for clusters or services which are running on top of clusters?
Mm-hmm.
And a follow-up question, have you thought about open sourcing this? Because it's bringing a kind of like backstage experience for the SREs and for the infra teams.
Yeah. So to answer the first one, I think there's just a lot of this custom functionalities that we wanted, like, for example, different ability to kind of confirm the deploys, or for deploying our stateful components, we quite often, like, we run 3 different replicas. And in the beginning, we would just like require manual confirmation between them and things like that. And as we were in early stages of the company, we really needed ability to have this control, right? And I think that would be harder to build in like maybe operator world. Even like with the operators that we have from 3 components, we're struggling quite a bit and considering actually moving that to a workflow because it's a little bit easier to test. I think that's what we experienced. It was kind of hard while writing operators. And now we're actually trying to automate more operations, and basically the deployer functionality is becoming a built-in block for it. So we would have something that would kind of detect what is the desired state of the cluster. Do we need to expand disks, or do we need to expand the M3DB cluster and maybe shrink it? And basically then there would be logic that is doing this reconciliation loop, and then it can use our deployment tooling as kind of a dependency to actually perform those operations. But I wouldn't be surprised if we decide to change it somehow. I think the struggle with the stateful components as well is that those operations take time, and then you really need to be careful, and I think there's more human involvement that is needed there, and it probably will stay like that for a bit. And speaking about open sourcing, we haven't thought about it yet because I think a lot of the code is like really specific to our setup. But maybe in the future, if you find something more general, I wouldn't be surprised if we do that.
Yeah, I was curious on the rollback thing. Like, do you have any changes to like the data model or database schema you have to deal with when you're thinking about whether to roll back? And if so, how do you handle that?
Yeah. With the database, that normally only for our kind of stateless tier where we have to deal with that. And I think in general, we are trying to be very strict about the fact that we want all the changes to be kind of backwards compatible, that it shouldn't be really problematic. But yeah, migration story is still something that we need to improve on. And it's kind of like, in general, I don't work just on deployment tooling, but on developer efficiency team, where we work in a mode where we gather feedback from teams, like what is the most painful to you right now? Let's prioritize that and then work on that. And we hear now that kind of migration experience is becoming more painful. It's only part of engineers at the companies that are affected by this, and that team on their own was owning their interactions with the database. But this is definitely not covered by this here. It just comes with the assumption that nothing will break. But hopefully we'll figure out a better way moving forward. We know it's a pain point for sure.
Thank you.
Yeah.
Any more questions? Parting words? You have 2 minutes.
I guess we have no questions.
All right, wonderful. Yeah. All right.
Thank you so much.
I used to work at Uber too.
Yeah?
Yeah, from 2017 to
I think we have an almost full room for this talk, so we can begin a minute earlier. So we now have Nena Ndukwe. Sorry, did I get that right? Yes. Yeah. Okay, perfect. From Slim AI, and she's going to discuss security best practices for production-ready containers, but also I just wanted to quickly ask Nena to also talk about Slim AI a little bit, if she wants to.
Yeah, that'll
and
be
cover that. Okay, perfect. Yes. Okay, wonderful. Yeah, so okay, let's begin. All right, take it away.
Thank you. Hello, everyone. I am Nena Ndukwe, and I am a developer advocate at Slim AI. So today I'll be sharing 5 practical examples of how you can get your containers more secure to be ready for production. So I'll briefly introduce Slim AI, and then I'll tell you a little bit about myself. So Slim AI was created to give developers the power to build safer, cloud-native applications with less friction, and complementary to our open source project known as Slim Toolkit. We have the Slim Developer Platform, and that allows developers to optimize their containers and get them more secure and ready for production. So by increasing the efficiency of your DevOps workflow and decreasing the attack surface, the whole point of Slim AI is to ensure that you're only shipping what you need to production. I do want to say, to be honest, I am super nervous. And the reason is because I have not spoken at a conference since the pandemic, pre-pandemic. So if you see me being nervous, just understand that I'm a little, rusty with this. But what I'm talking about is coming from the heart. So I'm going to continue now. So the whole point of Slim AI is to automate the process of shipping lightweight, secure, and optimized containers. And I'm going to go through the different tools that we have to do that. But a little bit of a background on myself. I am a software engineer, and I made a career transition, a pivot into developer advocacy recently, and now I'm in the cloud native space. I was in other industries before, so cloud native is super new to me and a little bit overwhelming, and I've been learning as much as I can about it. I've also noticed that there's this influx of developers who are super interested in DevOps and DevSecOps, which I think is pretty cool because I'm a part of that crowd too. And I feel like we need as many resources or access to resources to level up on those skills. Coming from the developer world, I would say I didn't have to interact too much with containers directly. That was something that DevOps engineers had to do, but we were shipping containers to production. So I've been documenting my journey about learning about containers, and I realized that there was this really huge opportunity as a developer getting into developer advocacy to learn about the experience of DevOps engineers and the pain points in their workflow. And I didn't realize until recently, learning about some statistics from the chief data scientist here at Slim AI, that most DevOps engineers or developers were when they were hardening their containers or slimming their containers, they're doing it manually. And that blew my mind because I came into this space joining Slim AI, where we're all about automating containers. So apps that are built by developers these days are wrapped in containers and they're shipped to production, but one can hypothesize if there are gaps between understanding of knowledge of developers and DevOps engineers' specializations, it's important that we focus on improving our container security knowledge as developers. When we do that, then we can empower ourselves to be able to build better things that are safer. So where does one begin if you want to learn the fundamentals about container security and how to optimize your containers? I feel like whether you're an expert or a beginner, it's good to take a step back and to look at the building blocks of container security optimization. And we'll be able to do that going through this, looking at seeing how we can leverage Slim tools. So first, we're going to break down a basic Python Flask application. We're going to look at this sample application and see how we can improve it by taking a look at the Docker file. And we want to know exactly what we're shipping to production. So we're going to scan those containers, and then we are going to analyze them and see what kind of vulnerabilities they have, what is the image sizes, and we're going to pick out of 4 Python-based images, which one would be the best one to build this Flask app. And then after that, we'll harden the container image using Slim Toolkit, and this is all about reducing the attack surface. So the idea is we'll start with one of the Python-based images, the official image, which is 932 megabytes, is quite a bit, relatively, and over 1,000 vulnerabilities. And we're going to reduce that to 25 megabytes with 0 vulnerabilities. I'm going to show you how we go through that process. So one of the things to first look at is how to improve your Docker file. And that's a really huge part of container security improvement. When we use this basic Python example, it's a very simple Flask app, and it implements a RESTful API. Since this app needs to run, it needs Python in order to run, we're going to look at the 4 different base images and then determine which one is the most lightweight and most secure. So now we're reviewing the Docker file of the official Python base image. And we see that it is using an official base image and a work directory that's defined, which is good. It has good layer construction and minimized cache invalidation. and it optimizes build performance. The files are copied in only as required, and we are exposing a port, and also we're using entry point, which is good for proper signal handling. But there's a few other things to think about when it comes to security, from a security perspective with constructing your Docker file. So one of the things that you want to do is avoid running your internet-facing app as root. Nobody is an unprivileged system account, and it's available by default in Debian, Ubuntu, Alpine, Distriless. And this is intended to run when you don't need any special permissions. It's usually reserved for services so that if they get compromised, the potential attacker would have minimal access to the rest of the system. And running your app as root obviously allows the potential hacker to have complete access to your container. When you are constructing this Docker file, it's good to choose a version number of your base image and pin it, which is what we call pinning. There are some tutorials out there that teach people who are newer to this space to use the latest image tag. But I feel that containers are meant to be created and destroyed. You should be able to start them and stop them, and they should be reproducible with ease and reliability. So using the latest tag is probably not the best case in this situation, since it isn't a single source of truth for the container's bill of materials. A new revision to the latest tag could introduce some major version bumps, and there might be some bugs or introduce some breaking changes into your app if you are always relying on the latest tag when changes are occurring and you're not aware of it. But if you pin a specific major or minor version in your Docker file, there is a trade-off for sure. You're choosing to not automatically receive system updates or language updates or upgrades. But most of the DevSecOps teams prefer to employ security scanning, and that is a way to control the updates so that we don't have to deal with like the unpredictability of some runtime failures or container building issues. So the next slide we're going to talk about, or I'll show you how pinning can be helpful in this case. When some people say to avoid update commands in a Docker file, I know that a lot of people in this space, or a lot of container experts, have debates about how you should properly, what a really good Docker file looks like. We could probably discuss that after this. But when you don't pin a specific base image and you don't have these update and upgrade commands in your Docker file, then whatever the latest base image is won't be maintained necessarily. So whether that image is maintained by large companies or by someone who has a side open source project, it would be their responsibility to go back to it and manually get it updated. And that can easily fall behind the versions of the versions that are used by other packages in that app repo. So when you pin a stable base image, then you can leverage the apt-get packages and update commands in your Docker file, and they will automatically handle security fixes and severe bug fixes. You can safely apply the system updates, and you won't have to really worry about any breaking changes, but you need to make sure that you're really applying the latest updates. And we're going to talk about layer caching. So as some of you might know, Docker builds can be kind of slow, and we use layer caching, and this is to reuse build steps that have already happened in order to speed up the current one. While this does improve build performance, there is potential downside, and that's something that is talked about sometimes, but caching can lead to insecure images. So for most Docker file commands, if the text of the command hasn't changed, the previously cached layer will be reused and in the current build. So when you're relying on caching, those apt-get commands will add old and potentially insecure packages into your images. So you can do that. Something you can do is you can bypass the caching by using a pull and -s pull and -no cache command options. And the pull is going to pull the latest version of the Docker base image and instead of the locally cached one. And then also the no caching will ensure that the additional layers in the Docker file get rebuilt from scratch instead of relying on the layer cache. If you add those arguments to the Docker build command for the new image, it'll have the latest system level packages and security updates. And if you want the benefits of caching and to get the security updates within a reasonable amount of time, what you would do is first you would use the normal build process for when you want to release new code. And then the second is every night you would rebuild your container image from scratch using Docker build, pull, no cache. And that will ensure you that you have your security updates. But now that we've gone over that, we're going to talk about what is going on inside of containers. So what we want to do is to be able to scan our container to know what's inside of it. And one of the ways you can do that is by leveraging Docker commands. And this goes through the vulnerability scanning, and it generates SBOMs in your production container. So Docker scan and Docker SBOM powered by SNCC and SIFT. But there's an alternative, and that is using the Slim SaaS platform. So for container scanning and a visual representation of what's going on in your container, we run this process using Trivy and Gripe, and we generate the results of this scanning process. You're also able to just get a deeper look into the files, the file layers, and also the packages. And what happens is you can see what every vulnerability by risk level. And you can also download the SBOMs that are generated if you need them for any type of security compliance. Now that we scanned the container, we want to understand what to analyze it to understand what the image size is looking like and what the amount of vulnerabilities are in each of the 4 Python-based images that we were just looking at. So one of the ways that you can do that, like I mentioned before, is the Slim developer platform, but you can also use our Slim desktop Docker extension. So this also gives you insight into the file layer system and helps you to understand how you will be optimizing your containers and then comparing the changes, because we have a before and after of the process. You can see how it was the vulnerability count was reduced and how your image size was also reduced. So now it's time to pick the best base image for your container, for your Python Flask app. So here we have the 4 that we're going to take a look at. We have an Alpine Python base image, and that seems to be the smallest here at 48 megabytes. Then we have a distro-less one, which is multi-stage build. We have Ubuntu. This one doesn't have Python in it, so we would have to add a command in our Docker file to be able to install and use Python. And then the bottom one is the official Python base image, but it's the slimmed version. So one of the things we would have to do as it relates to the Ubuntu base image, since it doesn't include Python, like I mentioned before, we would have to install that. And we can do that using this command. But one of the things to pay attention to is that what we want to do is make sure that we're not installing any recommended packages. So this will help to keep the image as small as possible. The fewer the packages, the better. So you can use the no install recommends option in order to do that. So that 921 or 23 megabyte Python latest base image I mentioned earlier is a good example of one that's quite large. So, of course, as you know, more packages, that makes the container image larger, and the larger it is, then the more it is at risk of, increases the attack surface. And so what you want to do is to, like I mentioned before, install the recommended, do not install the recommended dependencies, and also with this example of installing Python 3 without the recommended packages, it actually ends up reducing the package size by 298 megabytes, I believe. So now we can look at building the app and see how the final image sizes compare to each other now that we've have the Ubuntu one set up. So this is comparing the 4 Python apps by image size. So now we are showing all of them, and they include not only Python, but also the example app and the dependencies, which I think about 11 dependencies. In general, we can believe that smaller is safer. So it still looks like Alpine is winning in this one at 60 megabytes. And also we see that Ubuntu is at 131 megabytes. So Alpine is looking like it's number one that we might want to use for our Flask app. A smaller image size should correspond to fewer packages, so that could also result in fewer vulnerabilities. So let's see what the vulnerabilities are looking like. Okay, so Alpine has 0 vulnerabilities, which is interesting, and Ubuntu has 24, but it also has no critical or high vulnerabilities, and there's a very specific reason for that. We also see what Descheduler has 47, 3 are critical, 5 are high, and then the official Python base image, the Slim version, has 82 vulnerabilities, so it's at the bottom of the list. So it looks like Alpine is still a really good choice to use as our as part of our Flask app. And it's interesting that Ubuntu has 24 vulnerabilities, but none are critical or high. And I think the reason is because we have 3 medium, I see here. There's also 13 low risk and 8 negligible, and so that's how we get to 24. But the reason why it's at 0 for critical and high is because it's commercially backed by Linux. And so that full-time security team that they have SLAs to make sure that we never are getting out high vulnerabilities or critical vulnerabilities. And that's for the supported lifetime of the distro. So there's low complexity when it comes to leveraging the Ubuntu image, and some of the others don't have that. For example, the official Python image that has 82 vulnerabilities is, I think, run by Debian, which is a community project, and they don't have the same amount of support that Ubuntu would have, so it would make sense that there would be more vulnerabilities here if that's not being managed and not being attended to. So we're thinking about considering Alpine, but also there are some issues. And Python and Node seem to have some issues when it comes to Alpine, and for some reason it results in significantly slower builds, and it also introduces some runtime bugs and some strange behavior. So Alpine might be better for a Go or a Rust app. So that's one thing that's a con that we see with this so far. But Alpine was going pretty far. It was pretty high on the list so far, but we'll see which one we end up going with. I'm sure some of you all have a prediction about which one we'll end up using. But so the whole question becomes, what could we do to get the best of both worlds? How can we get the low complexity that comes with Ubuntu because they have so much support to make sure that there are no critical or high vulnerabilities? And how can we get the security profile and the size of Alpine? Alpine is super small and also a very low amount of vulnerabilities. And the answer is optimizing and hardening your containers. When we slim our containers, then we'll get a better idea of which image will be our best case for using that for our Flask app. So we're going to use Slim Toolkit and the Slim Developer Platform in order to harden our container images. With this command, what basically is going to happen is that we're going to take the image and target the image, and we will then create a temporary container. And there are Slim sensors that will be injected into the container, and it will be monitoring everything that is needed in order to run the container by itself. You also have to start the container. The observations will happen, and you need to also stop the container so that the sensors understand what's needed to actually stop the container. So then that's going to collect all the artifacts it needs, and then it will build a Slim version of the container image. And the reason is because we don't want to ship code that we don't need. So that is one of the biggest things about slimming containers, is if you don't need certain code, then why not remove it? And that's what Slim does. And of course, the benefits of having a slimmer container is that it's faster to deploy and, of course, fewer files. Also, this results in saving costs. Because it is faster, because it's smaller, you'll be able to store it and transfer it, and it'll be less expensive. And the big thing here is security. So Slim containers reduce the attack surface and the vulnerability count, and especially with unnecessary tools and utilities in libraries that get removed, then that results in less vulnerabilities. So now we will compare the Python app by the slimmed image sizes. We did all 4, and it looks like Alpine is still at the top with a slimmed size of 19 megabytes, but also Ubuntu is only 6 megabytes larger than Alpine, which is something pretty interesting. So not too far off from the size of Alpine, and that's something I think that's worth noting here. But in general, all of these apps have slimmed and been reduced by like 3 to 7 times. So in general, when you run them through the slimming process, you're going to end up with a smaller image. And now we can see what the vulnerability count looks like for these 2 top choices. And we see that both of them have a vulnerability count of 0. It looks like the Ubuntu image got rid of the 24 vulnerabilities that it had that were not critical or high, which is pretty interesting. Yeah, so those 3 medium risk vulnerabilities were removed. And what you can do is you can look at all of these results in the Slim platform, and you can analyze the difference between the vulnerability diff before you have hardened your image and after you've hardened it. And I think that's a really important information to see how the percentage of the reduction in vulnerabilities and also how the results of slimming your container to make it more ready for production. So we had the Ubuntu-based image that had no known vulnerabilities now, and there's a comparable size to the Alpine image. And I think that because of the issues that Alpine has with Python, and Ubuntu now having 0 vulnerabilities, that might be the actual best case scenario for using that with the Flask app. So let's take a look at what we learned. We learned that there are different techniques to utilize to improve your Docker file when you look at it from a security perspective to reduce the attack surface for your application. We learned that there are scanning and analysis tools that are available to us to review what kind of vulnerabilities that we have in our packages and also the risk level of these vulnerabilities. And we're able to also able to harden these containers and these images to understand how we are further reducing the attack surface by making these images smaller and by getting rid of or remediating the vulnerabilities. And this also shows that you can slim Alpine and Descheduler containers. That's a bit more than 5, but that goes to show you that there's a lot of benefits to thinking about these things from a security perspective and normalizing this process of hardening your containers when you want them to be ready for production. And I understand that manually hardening things is very tedious and very costly, and also it's something that not a lot of people have certain specialization in. And when you have tools like Slim, the platform, the desktop extension to give you further insight into your containers, and also this hardening process, then that can really help to mitigate some of the issues that you run into for DevOps and their workflow. And that is all I have. You can find us at Slim DevOps on Twitter. And we also have a Discord community. And we have the Slim Developer Platform that you can sign up for and try and play around with either your own private images that you have in your own connector registries or public images that are available on the platform. That's pretty fun to play around with, and you can go through the hardening process and see the vulnerability diffs and all of that. And as well as Slim Toolkit, which is open source, and you can take a look at that on GitHub. And that is all. Yes. Yes.
So in one of your slides, you were calling out the process. In one of your slides, you were calling out the process of Slim build, and one of the sensors looks for assert, right?
So is there a way to turn off that sensor in the case that you might be using a service mesh? Because with the service mesh, you get a sidecar, and that sidecar gets the cert injected instead of actually having the main container have it.
So you're saying, is there a way to turn off the sensor?
Yeah, or is there a flag that I could just not check for certs so that I can bypass that test and then allow the actual container to build?
You know, there might be, so the thing about this Slim toolkit is very robust, and there might be some command options that allow you to do that. One of the things is that I was doing a lot of research on what is actually available, and I was very shocked to see how granular and advanced some of these commands are for Slim toolkit. So I wouldn't be surprised if that was available, and some of our engineers who are deep in the code when it comes to this can point that out. And we also do have some documentation that would bring out some of that information.
Awesome, thank you.
Yes. Oh, she's got it.
Thanks. Can you mitigate some of the hardening by just running Slim toolkit? As you started the presentation by showing, okay, we're taking care so that we don't run as root, we not adding extra packages which are not required, but by just running Slim toolkit on, for example, the first image that you show in the beginning, can it actually help you to mitigate some of, for example, for people who are not so experimented with Docker and don't know how to harden their image, can just Slim toolkit help with that? Just to remove some of the problems that...
To remove some of the vulnerabilities. Yeah, that's what the Slim build command does. So it takes care of all of that with this one command. We also do have a Slim CLI, which is slightly different, but uses some of the same tools that were used to build Slim toolkit. And if you run a few of those commands, that interacts with the developer platform, and that allows you to like automatically harden your container. So you don't need to be, the point of this is that you don't need to be an expert. You don't need to be a DevOps expert in order to do this. Looking at the documentation, you run the commands, and it works. And I think that's a very important thing because not everyone is specialized in this. And it does automatically remove the vulnerabilities. And of course, not every container is going to end up with zero vulnerabilities, but the purpose is that it's reduced. I hope that answered your question.
I think we have a few more minutes, so if there are any other questions, if you probably want to discuss something more or with the crowd.
I think there's someone back there.
Where? Am I missing something? Okay. No, I'm not sure. Do you have a question, maybe? Okay. Okay, we'll be back in 10 minutes then for the next talk. Thank you, Nina.
Thank you.
All right, everyone. And for our last talk for today in the suite, remember we have another talk after this at the main room only. But this is the last talk here at this room. We have a talk on Descheduler, and we have Lucas Severo Alves and Jan Chalupka talking about it. And yeah, this is a half-an-hour session, and we'll be done after that. But feel free to get a drink, get a coffee, get some refreshments after that, and join everyone in the main room. Just want to remind everyone that there will be one last session in the main room after this. This is the last session for this particular room. All right, then, take it away.
Thank you. So welcome to our talk about the Descheduler. Descheduler is this project that we help maintain. It's basically a project that helps you place your pods at the right place all the time. So a brief introduction. I'm Lucas, this is Jan. We work at Red Hat as engineers, and we are involved in this project, Descheduler, Jan since the beginning, and I'm now helping develop this new framework for the scheduling. So the basic idea here is that scheduling in Kubernetes evolved a lot. You have topology spread constraints to help you spread pods. You have scheduling being aware of affinity, taint, and all that. But the thing is, after a pod is placed, that's it. Unless you're considering preemption and all that, we are not talking about that. But if a pod is placed, that's it. So thinking about that, we can go over an example just to feel what we're talking about. So if you have a deployment, and inside the deployment, you can configure a topology spread constraint. And if you're not familiar with this, I'll explain a demo or an example of how this works. But basically, you want to spread your pods with regard to a domain, a topology key, in this case, zones. So thinking about availability zones. And here we have max queue 1. So the maximum difference between the number of pods in a zone and another one needs to be at maximum 1. So let's say we have 3 zones, 3 availability zones, and the number of nodes in these zones doesn't matter that much. So we're basically thinking only about the zones. And we get a pod, and KubeScheduler will make a decision, okay, which node, or in this case, which zone to place this pod. Let's put this pod at zone A, then the next pod will go to zone B, obeying the max queue 1, and the next pod at zone C. And if we go over this for a few times, the fourth pod can go to any of these zones because max queue 1 will still be valid. And eventually we'll have this scenario, 6 pods, 2 in each zone, and this is perfectly balanced, and this is what you want. So topology spread constraint helps you to get that. So let's say, what happens if you get a new zone with new nodes, but no new pods? So this is an unbalanced environment. You have a new zone that has no pods, and all the other zones are full, let's say. KubeScheduler will not rebalance this. This is placed. KubeScheduler just gets pod and will place a pod in a zone or in a node. The scheduler comes for the rescue. So KubeScheduler will install it in your node, and it will keep looking for pods that are offending one of the rules that you set. So in this case, the scheduler will literally fire a laser beam at your pod. I'm very proud of that smoke. And it will the pod will go back to pending, and the KubeScheduler will place the pod in a new zone. So the idea here is this scheduler is not aware of KubeScheduler. KubeScheduler is not aware of this scheduler, but we are taking advantage of how things work. So you're just evicting pods that are offending one of the rules that you set. KubeScheduler will pick that up and place in a place that makes sense for you. And then thinking about some other ways that this scheduler can help you. So it's still in availability or spreading pods around your cluster. Maybe you're not thinking about zones. You're not thinking about topologies and all that. You're just worried about, okay, replicas from the same deployment should be spread around. So this scheduler can help with that, and it will evict pods that are maybe replicas in the same node, and then KubeScheduler will place them in new nodes. So you have more spread out topology. Removing pods that are in your cluster, and then you notice that you have underutilized nodes. So the scheduler will notice that, will evict pods from heavy utilized nodes, and those will move because kubescheduler will place them in nodes that are underutilized. Some other example that it's basically the same, the one from the beginning, but maybe you have static zones, you're not having new zones, but you're thinking about, okay, we have AZ degradation, we have evacuation, but then the AZ is healthy again, and we need something to just gradually balance the workloads. And you don't have to think a lot about that. This scheduler will just do that for you. And then when you think about costs, you want to be cost efficient. You want to use as little as you can of like expensive instance types in your topology. So you have some nodes that are very underutilized, like so just a few pods there, and those are expensive instances, and you want to just like move them around to nodes that could be more cost effective. And you kill those pods, they will move, and then you can use something else to remove the nodes. And exactly like that, like as a companion to these scenarios, if you're bin packing pods, you want help deleting nodes. So probably you're thinking about cluster autoscaler or maybe Carpenter to help with that. Or if you're like you need to scale up and like have pods spread out on a lot of nodes, you want help like to add nodes to your topology. And yeah.
Okay. Thank you very much. So far, you've seen some use cases that can be solved by the Descheduler. So now let's go through some existing strategies we have and how to configure those and so on. Right. So like there are some strategies. So for example, we have remove duplicates, which makes sure that if there are nodes which have more duplicates of a pod than others, the strategy will try to rebalance the pods. The low node utilization makes sure that the pods are evenly balanced across nodes with respect the resource utilization. High node utilization was mentioned before. With the yes, sorry, and remove pods avoiding topology spec constraints was mentioned as well, but it tries to minimize the maximum skew between pods across the topology domains, and the pod lifetime, which makes sure that if a pod has been running for too long, it is evicted as well. Right. So here, so in the past, we had a V1 Alpha 1 version of the policy, which allowed you to only specify like a list of strategies that are run, but in version V1 Alpha 2, we decided to introduce profiles. So, like in short, this is a file, and so on the global scope, we allow to configure things like a maximum number of pods that get scheduled per a namespace and others, and in each profile, you can actually specify like a list of strategies, like including a configuration of strategies, and then a list of stages in which the plugins or the strategies are executed. Right. Like additionally, you can also configure the namespace filtering, which allows you to either include or exclude namespaces, or node fit, which allows you to actually tell the descheduler to before it tries to evict a pod if the node has sufficient resources for scheduling a new pod, for example. Now, like all the strategies that were mentioned here were turned into plugins, which allows you to actually wrap the descheduling policy into a separate code, which allows actually for creation of a framework. So here you can separate the policy from the rest of the code, and additionally, you can also build your own plugins, which allows you to specify actually your own way how you want to evict pods. So, for example, you can evict pods based on incoming traffic, or you can define your own way of how the pods are sorted or filtered, for example, based on metrics. Or you can, if you have some internal policies which cannot be exposed publicly, then again, that's another use case for you, right? Like here, in short, if you are familiar with this, the scheduling framework, then you can see that the structure is almost the same. So in short, you specify the plugin type, then the framework, once your plugin is part of the framework, then injects the handle and arguments, which you can then parse in a way that you like. And then you basically define the first level extension points, like the deschedule and balance, which are invoked directly by the framework. And you can also define a second level extension points, which are invoked from within the plugin. So now here is a list of extension points which are currently implemented in the framework. So for example, the deschedule allows you to build a policy which is descheduling a pod independently of other pods, whereas the balance extension points allows you to actually take other pods into account. Yeah. Those are the first level, and the other are filter, which allows you to filter the pods at the beginning when your plugin starts to process pods. The pre-eviction filter is executed right before a pod is evicted, and there are upcoming sort and pre-eviction sort, which are sorting before pods are processed, and then right away before they are evicted. So and then we can combine plugins into profiles. As I mentioned before, there was a V1 Alpha 1 version, which allow you to only use one plugin only once, but with the profiles, you can use the same plugin multiple times, just with a different configuration, and at the same time, you can also use the same plugin with different extension points, which actually allows you to even more customize the behavior that you want. And again, as Lucas mentioned, we are building a descheduling framework. It's still a work in progress. So if you take a look at the upstream issue 753, there's an ongoing discussion with links to the design proposal. So if you are interested in joining the effort, just feel free to take a look there. We are also planning to provide ability to specify out of tree plugins, so you can build your own descheduler to your needs. So if you have some time, just feel free to build it and experiment with the framework. And if you are happy or even unhappy, just let us know. Okay.
Yep. So this is just a quick demo with the pod lifetime plugin, because it's the simpler one. And one sec. So the idea is that on the right we have a few Nginx pods running, and on the left we are doing the actions. So first we are just installing the project with Helm, and we are setting the deployment type to be deployment, because you can also run as a cron job in some other ways, other install types. And then we are getting the pods on kube system namespace, just to see that the scheduler is installed. It's there on the bottom, and it's running. It's basically a pod running this loop recurrently and checking for pods that are like offending one of the rules that you set. And we can see the logs of that the Descheduler, just to see that it's running. For now, it's not evicting any pods. Like the eviction is 0 for now, the eviction count. And pods are running on the right, and that's fine. Then we can actually have a look on the configuration. It's a config map. As Jan said, it's a config file that you pass for it. And the pod lifetime is set for 80,000 seconds. So it only, for this strategy alone, it will only evict pods older than that, but now I moved to 15 seconds. I will restart the Descheduler, just so it's running with the new configuration, and then pods start to be evicted, and then rescheduled by the kubescheduler. So so the age there, when it's over 15 seconds, and of course when the Descheduler is a new refresh interval, it will take a bit longer, maybe 17 or 19. It run, and it will be evicted, and then they will be rescheduled. Yeah, it's very simple. But then when you have more complex rules, it will like be a bit more interesting, like topology spread constraint and all of that. And yeah, so the idea here, just to show a bit of the code for pod lifetime. This is the simplest plugin. And basically, as Jan said, you define a name for it. You check that you're implementing our interface like correctly. Then you implement the methods that we expect with the right signature. So the one that you need to implement is new to build the plugin. Here I'm setting some filters, like let's say default filters. But the interesting one is this one, the custom filter, that we already save. This plugin should filter pods that are newer. It only includes the older ones. So this is already the set of pods that you want to evict. And then you're implementing the Deschedule extension point. So this is a plugin that is evicting a pod only based on the pod status, not considering other pods. And then you're just like organizing pods and sorting them to evict from the older ones to the less old ones. And that's basically it. It's a very simple plugin, and implementing a plugin is as simple as that. Then back to the presentation. Doesn't go to the next slide. Okay, so roadmap for the project that could be interesting. Yeah, we are adding OpenTelemetry tracing. As Jan mentioned, we are like going to this new descheduling framework to give more customization and like ways for users to have like closed or open source plugins of their own. And because of that, we had to have new ways to configure the project. So we have V1 Alpha 2 in place. And at some point, we will deprecate and remove V1 Alpha 1. For now, it's supported. We have more node fit options. So node fit, it's an option that gives a lot of discussion in the community, because like considering other nodes and considering if they are schedulable or not is a discussion that we have like a few issues and open, and it's very controversial. And we want to add more options so people have more flexibility. And of course, we want to start a custom plugin registry initiative. So we don't want to have a new repository with new code to maintain with a lot of plugins, as KubeScheduler has nowadays. We want to have a reference, and people can implement their own repositories, their own plugins, and we have a reference to those and a registry, and we can say which are in beta, which are stable, and this kind of stuff. And of course, we need new maintainers, and we need new people to just talk to us about how they are using this scheduler. So we are basically at the SIG scheduling channel on Kubernetes. We are a SIG sponsored project, so we are under the same SIG chairs. The community meeting that we have is once a month, so the next one is on May 9th. But we also share a bit of the community meeting with the SIG scheduling folks. And please reach out to us, and we would like to understand a bit more how the scheduler is being run on big clusters and some other topologies and other scenarios. So yeah, that's it. Thank you. Any questions?
Hi, cool talk. Is there a way to tell it to only consider pods on a particular subset of the nodes? I know you could probably write a plugin to do that, but I didn't know if it was something you guys were already doing.
Do you want to answer this one?
Yeah, I can actually maybe go back. So there's a node selector field, a global way of the configuration, and it was go
one more, yeah.
One more, yeah.
Node selector.
Does work? Yeah, here the node selector. So yeah.
You can also have labels selectors. Yeah.
Perfect.
Yeah.
A very cool project. Just a quick question around thundering herd kind of situations. If you have one availability zone that's sort of degraded, can you end up in a situation where you've got this kind of ping pong happening between descheduler and scheduler, kind of moving stuff back and forth all the time? Can you sort of throttle that with global config or something to try and slow that down, or?
Yeah, you can probably exclude that zone from the descheduler being so it ignores it for a while until it comes back. It can also pause the scheduler for a while. We also saw some people doing that. Yeah.
Cool.
So that's basically it. Yeah.
We do have a few minutes, so we can take more questions.
Hi. So here in the pod spec, we have a field for the affinity required during scheduling, ignored during execution, and another similar one. Is there also on the horizon that there will be a similar one for the descheduling process?
We actually have remove pods violating affinity rules. And we just showed the most famous ones, the most popular ones, but it's one of the strategies that we support. So we will evict pods that are violating affinity.
So it's also available in the pod spec directly?
No.
Okay.
You configure so this scheduler will evict those. Evict pods that are violating affinity.
Mm-hmm. Okay.
I've had times when one of the worker nodes was quite full, let's say for memory, and then you just have to cordon that node and then kill some process to make sure it goes to another worker node.
Yes.
That is one of the cases you can be established with it.
Yes. So it's one of the examples. It's the contrary, the other side of bin packing. It's actually evenly spread pods. So we noticed that other nodes are underutilized, and we evict pods from overutilized nodes, so they go to the underutilized ones. Yeah, that's basically it. It's the low node utilization strategy. Yeah.
On that topic, what are the possible ways you configure the node underutilization? CPU memory?
CPU memory or any CPU memory and...
There are also extended resources, any extended
like
resource.
GPU. But you set a high threshold and a low threshold, so you consider what, so you know what is an underutilized or overutilized node. Yeah.
Any other questions? We have about 5 minutes left for your talk. If you'd like to discuss something or play around more with the demo you just did, or talk a little bit about the plugin that you were talking about and brainstorm some ideas, absolutely go for it.
Yeah, so right now we are looking for, like, we have some information about users and customers that use the project, but it's still very little. It's double. Yeah, so we consider that we still have very little information about how the Descheduler is being used. We know that it's heavily used, but we don't know like a lot of information. So we wanted to know a bit more of users and how they use it. We have a few metrics here from one of the maintainers that is also a user. Like he used in a very big cluster with like more than 40,000 pods. What is it? Pod count. So 40,000 pods, and we have some information about like resource consumption and like which strategies evict pods more when they have errors and all. But we want more of this generally, and we want like help running like tests in real environments in big clusters. So this is a project. It is also shipped by, not by default, but it's one of the supported operators for OpenShift. So you can go on Operator Hub inside OpenShift, and it's an official operator. Install the scheduler there. And then there are a few, we don't support all the strategies there. And then because of this, we have some information. But yeah, we wanted to get more use and more like discussions and understand how the project is doing on the wild. Yeah, basically.
Also,
Go ahead.
So we also have a resource consumption of running the Descheduler actually over this huge cluster, and I can see like the CPU consumption is, let's say, low. It's fine, but if we take a look at the memory consumption, it's like quite high, like over 1.5 gigabyte of memory, up to 2.5 sometimes. But we also get a resource consumption of the Cube, the scheduler, and it's quite. Like it's also above 1.5, so like we are not doing so badly, but like there's always some space for improvement. So again, once the descheduling framework is done, then like we plan to actually improve the memory consumption and trying to go down. So it's like.
It's because, especially the strategies that are balanced strategies, because we want to, when we are like going over the algorithm, we need to consider the whole context of the node. We need to know, like, to know if the cluster is balanced, you need to know the place of every pod on every namespace and every zone and all that. And then the pod informers and also the way that we work with the arrays and maps. So some things can be optimized, yeah, of course.
How severe is the impact on like etcd if you've got a really big cluster like this and you've got Descheduler running as well as like ordinary Descheduler and you've got a whole movement with pods? Is it noticeable or?
I don't think it's that noticeable, but we want more information on that as well. Yes.
Can you rate limit the descheduler? Like I only want you to deschedule this amount per.
Yes.
Okay.
You can. Like maximum pods.
Yeah. So it limits the number of pods that will get evicted, but it will not decrease the resource consumption.
And not the resource consumption.
It will be the same.
You wouldn't have the thundering herd of too many things getting
going.
Yes, that's true.
Yes, that's true. Yeah, there's some configurations where you could make the kube scheduler work against the Descheduler, like if you don't properly configure them, because then you're just killing a lot of pods every time, and then KubeScheduler is trying to place them in any way, and then Descheduler is killing again. So you have to be aware of what configuration you're giving the Descheduler and what configuration you give to your deployments and how KubeScheduler will place pods on nodes and zones and all that. Yeah. Yeah.
All right, I think that's perfect timing. That's all we have time for. And thank you all for coming and attending day 1 of Rejekts. These were all the talks that were scheduled at the suite here. We'll see you tomorrow again at the suite and at the warehouse, which is downstairs, for more talks starting at 9:30 a.m. That's about it for now. Gentle reminder, just one thing. We have one last talk happening at the warehouse at 6. So yeah, if you want to just quickly go in there, pop in and join that talk, that will be the last talk for today. And we'll see you for more talks and networking tomorrow. Thank you.
Yeah.